Australia is a nation of creators, aviators, protectors and innovators. From aviation's first light to the dawn of the jet age and beyond, at Boeing, we're building the future together here in Australia. Inspiring those in pursuit of new frontiers, connecting, protecting and exploring our region and the world. Home to the broadest aerospace portfolio in Australian industry, powered by talented, dedicated and diverse teammates. Delivering manufacturing excellence, building composite aircraft parts for the world's most efficient airplanes, using advanced robotics, materials and digital technologies. Never compromising on safety or quality, always focused on sustainability. Solving tomorrow's problems today with Australia's leading researchers, scientists and universities. Developing new military platforms and communications networks and helping ensure they are always mission ready. Keeping customers airborne by providing the services they require. We stand shoulder to shoulder with Australians during natural disasters, on the front line and in peacetime. We support veterans and our community, and we nurture the next generation of aviators to excite, to be bold. Boeing Australia. Made in Australia, by Australians, for the world.
Okay, are you ready? The first university to admit women, 2 Nobel Prizes, then another, then a couple more, 12 knighthoods, 22 Olympians, a pack of COVID-sniffing canines, Australia's first female Prime Minister. Finally, treatments for diseases and other scary things, the first female Queen's Counsel, Supreme Court Judge and State Governor, all in one, first in the family with a degree, a black belt, a robot. First Aussie to walk in space, helped detect gravitational waves, made lots of babies, world top 100 in all this stuff. Launched a satellite, revived lost languages, home to 1600 brainiacs, and a winery, all in the heart of Australia's most livable city. So, what's next? Make history at the University of Adelaide.
Hello everyone, my name is Henry and welcome to the third day of the Australian Rover Challenge. We are here bringing you the Space Resources task today. Monash Nova Rover from Melbourne, Australia are our first team and they'll be starting the task at 10 a.m. Australian Central Daylight Saving Time. That's coming up in just over 10 minutes. The Space Resources task sees teams navigate to a couple of sample sites, prospect them, see if they've got any water available in those sites, which they could potentially bring on board the rover and then process this to get and extract that water. So we'll see the Monash team navigating the area today, looking for those sites, and then seeing how much water they have and whether they can excavate them. The team is still in their setup time, so their base station is hard at work behind the scenes here, making sure they can establish communications with their rover, and then 5 minutes before the task, we'll see them lift the rover onto the lander where they will begin the task at 10 o'clock. There are 100 points available for this task today. 5 points available for descending from the lander and getting onto the field. Then there's 10 points to navigate, 10 points each, to navigate to each of the sample sites. Further points available to image those sample sites. There's 40 points available for the processing, and that's just a measure of how much water the teams are able to get out of the samples that they excavate. And then after that, the teams will do a presentation on their findings. What was available in the sites, how much water was there, what was their process to identify, what was their process to get that water. And they'll present that to Daniel, our expert judge, and he will mark them on a score from 0 to 25. Hello everyone, welcome again to the third day of the Australian Rover Challenge. My name is Henry and I'll be joining you today to give you some insight into what the team is doing and competing. First up we have Monash Nova Rover from Monash University in Melbourne, Australia. They're currently sitting on 248.8 points. That is currently first place, and they'll be starting the Space Resources task in just under 5 minutes' time. You can see the team here have their rover on the lander, which is the start gate for this task. And they're still establishing communications with the rover and going through their boot up procedure before the start time at 10 o'clock in 4 minutes' time. There are 100 points available for this task. The first 5 points are for descending down the ramp onto the lunar surface. The next 30 points are for navigating to and then identifying the 3 sample sites that we have out on the field today. 40 points are available for excavating from one of those sample sites and then seeing if they can extract water from that sample. And lastly, 25 points are available for a presentation about their findings to one of our expert judges here at the Rover Challenge. The aim of this challenge is to simulate obtaining water on the lunar surface, which is an aim of the upcoming Artemis missions. Water is extremely valuable on the lunar surface. It can be electrolyzed into its components, hydrogen and oxygen. The latter, which can be used as an oxidizer, as a rocket propellant to leave the moon or even go to another celestial body, or be used for life services such as to add to the air that we breathe. Hydrogen can also be used as the fuel in a rocket propellant. So that is also useful on the lunar surface. And of course, the raw water can be used to sustain life as well. You can see the Monash Nova rover is on the lander, and it looks like the team are about to start the task. They've just finished their final pre-task checklist, which appeared to check all of the motors to see that they're in working condition. And we should see them any moment now confirm with the base station that they are ready to start the task. The task goes for 40 minutes, and we'll have the timer running in the top right-hand corner of your stream there. So you can see the Monash Nova rover is descending that ramp to get the first 5 points of this task. As soon as all 4 of its wheels hit the lunar surface, those 5 points will be awarded. Give them another round of applause. So the Monash team has made their way very quickly over to the simulated crater that we have on our challenge arena, and they're looking at sample number 3. So the Monash Nova Rover is one of the rovers that has pivot steering this year. So you can see that the wheels are actually pivoting about the vertical axis there to enable it to maneuver very delicately into the right spot that it needs to do to be able to see that sample, check it, and see how much water could possibly be in there. So it's just lining up for sample number 2. So there are 3 samples in our simulated crater with 3 varying water concentrations. One might be plentiful with water, one might have none at all, and one might be somewhere in the middle. The teams don't know, and that's their task to figure it out. So it looks like they've made a visual inspection of site number 2, and now they're going for site number 1. So you can see their science payload is on the front of their rover, that trapezoidal shaped thing on the front there. And they're lining that up to make sure it's right over the sample so they can see the sample on the ground beneath. And with that, it looks like they've made a visual inspection of site number 1 as well. So they're making light work of this task. Just over 5 minutes in, and they've had a peek at each of the 3 sample sites. So they might have a clue as to which one has the most water. You might be able to tell by the colour of the sample, for example. You might expect it to be a little bit darker if it has more water content in it. So you can see the Monash Nova Rover's base station just there. So they've got about 7 people in there, plus one of our judges, operating the rover. So it takes quite a big team behind the scenes to make sure that their video feeds are correct, they're able to move correctly, and then they'd have specialist science operators as well to operate that specific payload. So it looks like the rover was having a bit of a more detailed look at sample site 3 there. And maybe the platform on the payload had lowered a little bit. It hasn't made contact with the ground, so they haven't actually excavated any regolith yet. So we'll wait to see what they do next. I'm actually joined by Ash, a member from Monash Nova Rover, a member of their science team, and she's just going to tell me a little bit about how the payload on the rover works at the moment. So Ash, can you describe essentially what is the payload trying to do?
Yeah, absolutely, Henry. Hi, everyone at home. I'm going to briefly describe what our science payload's designed to do. So we've got two kind of separate systems. We've got our water analysis and extraction systems. So our analysis system is comprised of a combination of imaging as well as a weight-based moisture detection system. So we excavate at each site. We then process our sample and then detect any changes in weight and make our kind of moisture estimations based off those differences that we calculate. We then have our extraction system that's powered mainly off a linearly actuated masonry auger that's able to really easily process the really hard icy regolith with a lot of ease, and that deposits into a kiln which we then extract water from.
Cool, awesome. Thanks for the insight, Ash. So that weight-based determination, about how much regolith are you excavating, and what sort of mass difference would we expect to see for different water concentrations?
Yeah, absolutely. The sensors that we have on board are really accurate, so we only need to really excavate about 10 grams of sample at each site to get a really good mass measurement. And we get to, like, with that small amount of mass, we really process it quite quickly as well. So we really try to optimize like accuracy versus like the time of operation.
Awesome, thanks Ash. So we can hear a bit of a noise coming from the rover right now. Can you describe what that might be?
There we go. This sounds like the start of our extraction system. So right now we're moving our masonry auger down to the sample site, and that sounds like it's starting to churn out some processed regolith.
So based on a preliminary scoring, I would guess that the Monash team is sitting around 35 points right now. They received 5 points for descending off the lander, and then they received 3 times 10 points for navigating to and having a visual inspection of each of the sample sites that we have in our crater. Their processing system seems to be in full swing now. So they are excavating some of that regolith, which is the lunar topsoil, and they are trying to extract water from it. There will be 40 points available based on the mass of water that they are able to extract from the regolith that they excavate. So Ash, you described before a little bit about how you might make a determination of how much water is in each site, i.e. the water concentration. So like I just described, there are then 40 points available to extract that water. Can you describe a little bit about how the rover is going to do that today?
Yeah, absolutely. So right now we're in the phase of collecting our sample. Once the sample is collected, we've got an a little kiln going on that heats up the sample. So this then turns the ice inside the sample into liquid water, and then from liquid water into vapor. So basically we're boiling a pot of regolith. The vapor then travels through a condenser system. So it's basically a large copper pipe that then cools down the vapor, turns it back into liquid water, and then that just filters through our kind of drip condenser into a little bucket, easy for assessing.
Awesome, cool. So would you say that this system is similar to any other products that people might be familiar with? Like you're heating it up, cooling it down to get that water?
Yeah, it's quite similar to the way you distill various beverages as well. So it's basically a water jacket cooled condenser. So it's pretty standard to things that people might already have in their houses. Yeah, definitely.
Cool. Did the team take any inspiration from any devices or any processes to make the design for the Rover?
Yeah, a lot of the design was actually kind of built off what we had done last year, where the condenser and kiln systems are all kind of out there. It's more so the challenges that we faced was kind of applying them together for this specific process. So a lot of the systems that we design take inspiration from things that already exist, but applying them to this kind of lunar context takes a little bit of creative thinking, especially when you're kind of taking inspiration from different fields, putting them together, it takes a bit of work.
Yeah, absolutely. Whilst each of the individual steps might be pretty simple on their own, it sounds like it takes a lot of work to make it into a whole complete system, which is then controlled remotely from a different location to try and get the water that we're all looking for. So interesting you said that, there are a lot of different disciplines in the science team. Can you explain, what type of background do a lot of the people have in the team?
Yeah, it's a very diverse team. I reckon it's one of the more kind of, in terms of disciplines, diverse teams on the Nova Rover team. So we've got people doing a lot of engineering students, but we've also got people doing geology, people doing biochem, people doing other types of science disciplines as well. And it really does take that kind of interdisciplinary team effort to pull off something this amazing. Yeah.
Absolutely. That's great to hear. Yeah, also cool that you get to meet other students that you might not normally meet in your engineering degree if you are doing engineering. And collaborate with them. They would have different experiences, different backgrounds. I'm sure there's a bit you could learn about them in the process.
Yeah, there's always someone who's got a little bit of insight into something, and it's really nice to have that friendly team environment to ideate and just churn ideas out and see what works and get that expertise from everyone.
Awesome. So we can see the Rover is still spending some time over there at Site 3. So they must have made some determination that perhaps they think Site 3 has the greatest concentration of water. For other teams in the crowd, the numbers will not be the same. So don't get any hints. Once the team has made that selection, which it appears as though they have, they can then excavate from that site and that site only, try and get as much of that regolith on board the Rover, and then use the process that Ash was describing to then heat it up and then cool it down again to get liquid water, which is how they're going to be scored for this task. So it looks like the team has actually called an intervention here. So the base station team at any time have the ability to notify the judge in their base station that they think the Rover isn't operating the way that they believe it should. And so we have a couple of Nova Rover team members who've jumped out onto the field to try and debug the issue here. That does come with a points penalty, so whatever the number of points that the team does score today will be deducted by 10% for each intervention that they take, but they can jump out on the field, diagnose what's going wrong, communicate with the people in the base station, make sure the Rover's working as it should, and then recommence the task. So in a lunar context, obviously we want our rovers to be able to operate by themselves and even autonomously in some respects. But there are definitely cases where, with most space missions, after they are launched, you essentially can't do anything else. They're just left to their own devices. In this case, we're fortunate enough to perhaps have some other astronauts inhabiting the moon with our rover. And so, depending on what is exactly going wrong and whether a fix can be made, a call might be made to send them out onto the surface to then check to make sure the rover's working, perform some maintenance, and then the rover can continue the task again. So you can see they've just unscrewed the top panel of the rover there, and this gives the maintenance crew out there a bit of a look into the internals of the rover. So their electrical systems, their electrical boards are going to be underneath there, and they can have a look to see what might be happening. So that base station team will have their radio on and communicating with their maintenance performers out in the field. Sounds like they're going through a bunch of diagnosis checks. That top plate is back on, and they might be looking to get underway again shortly. Once that team is happy that the rover may be operating in its optimal or correct state again, they'll give an indication to our judges that they're ready to go. They'll clear the field. They'll switch off those radios so they break that line of communication, and then they'll be able to operate the rover again for more competition points. So it looks like they're just exiting that intervention. Let's give them a round of applause for solving that issue. And hope that that rover might be able to collect some more regolith and process it for some more water. So there are 40 points, a reminder, 40 points available to extract as much water as possible from that sample site. I can hear something coming from the rover, so it sounds like things are happening again. I think it's that auger that's on the front of the rover is pulling up more of the regolith into that science payload that they have. Team still has plenty of time to go, so we've got over 17 minutes left in this task. So they'll be trying to use that time to get as much water as they can to maximize those points. So there's a reason that our sample sites are located in our simulated crater in the challenge arena, and that's because near the poles of the moon, there are some areas called permanently shadowed regions, or PSRs. These are areas which never, and I mean never ever, receive any sunlight at all. What that means is they're extremely cold, about or more than, I think, minus 150 degrees Celsius. And it means that water ice potentially exists there in quite some large quantities, because it's never seen the sun, never evaporated, and because it's so cold, it's stayed there in ice form since it was deposited a long, long time ago. I can hear the science payload still doing its thing, so I think it's still drilling to get some more regolith up into the payload. So that's just gone 15 minutes left in the task. Let's see how much water they can get in this short time. So the Monash Nova rover has pivot steering, which you can see those four wheels are pivoting along their vertical axis. It does look as though the front left wheel may not be pivoting in the correct way, and that possibly could have been the reason why they jumped out earlier to perform some maintenance on the rover. Nevertheless, the science payload is still making noise, it's still whirring away. So let's hope that they're still processing that regolith, to extract that water that they're looking for to earn the points in this task. You can see the base station team here. I think they are using a simple Xbox controller to control the rover. So the rover is moving back from Site 3 there. Maybe it's collected all that it needs. Or maybe they could be going to realign and go for another dig, which is what it looks like they are doing. So because they'll be using a drill bit just on a vertical actuator there, it's likely that it will take a small core or a small cross-section from the whole sample itself. So because they have no lateral movement in that drill, they'll have to reorient the entire rover to be able to get another section from that sample. The payload is once again whirring away, which indicates that they are lowering the payload to the surface to collect more regolith, bring it on board, hopefully heat it up, condense it, and be left with liquid water at the end of the day. That liquid water that they're trying to get is just so valuable on the lunar surface because it can be used in such a variety of ways. Not just to support human life for living, but also it can be used to be turned into rocket fuels to either return scientific equipment or other lunar samples to Earth, or potentially even go beyond the moon lunar system over to Mars or otherwise. You can see the team cheering there. Looks like they were able to take another big bite. And there's still plenty of time left on the clock, so let's see if they can go ahead and take a third even. With 10 minutes to go in the space resources task, it looks like Monash Nova Rover are well on their way to earning a good score. I can tell you they've definitely scored at least 35 points, 5 points for descending off the lander onto the surface, and then 30 points for investigating the 3 sites that we've laid out on the competition surface there. For the last little while, they've been trying to excavate some of the sample that we've put out for them, which has a known quantity of water. They'll then bring that sample on board the rover and try and process it to get some liquid water, which is how they'll be scored. I'm sure their base station team are thinking very strategically right now, thinking about how they can maximize their points, but they also don't want to damage their rover in the process. This is the 3rd day of the Australian Rover Challenge, so we've been through 2 of the tasks already. The first one being the post-landing task, where the rover had to descend off the lander just after it's landed and navigate around our challenge arena, investigating the other supply caches, i.e. the other objects that have already been sent to the lunar surface before the lander and the rover itself. Yesterday we saw the teams compete in the excavation and construction task, which was simulating an excavation type activity on the surface. So they were pointed out a regolith acquisition zone, or a RAS, where they had to use a bucket or drill or scoop or otherwise to collect as much of a sample and deposit it to the processing plant. So in this shot here, you can see the metal container which is housing that sample that they've been looking at. And we're getting a great view of the rover itself. link with the rover. And once they're ready to go, they'll let the judges know they're ready to begin the task. So the UTS team is still yet to get underway. They've got 23 minutes left in the task time. That's finishing at 11:25 Adelaide time. And everyone in the crowd here is wishing them the best of luck to try and get the rover working so they can begin the task. So this year we have 8 teams competing in the Australian Rover Challenge. UTS are the second team to get underway today. They'll be followed by UQ starting the Space Resources task at 11:30 a.m. Followed shortly by Project Scorpio, our team from Poland this year, who will be getting underway at 12:15. After that, we'll have a short break for lunch between 1 and 2 before we have the second half of the teams underway in the afternoon. So the UTS team are going to pick up the rover now to make sure that their drive is working. and potentially soon after that, they'll be beginning the task. So we've got 8 teams in the Australian Rover Challenge this year. The Australian Rover Challenge has grown every year. So in the first year, back in 2021, we had 3 teams. That was Monash Nova Rover, RMIT, and the University of Adelaide. Last year in 2022, we had 5 teams, and now we're up to 8 teams, including 1 international from Poland, Project Scorpio, in 2023. We've got some big plans coming for the future years, and we want to encourage international teams and Australian teams to come on down to Australia and see what we've got, and make a super competitive competition so that everyone can grow and succeed. Now, I can't stress enough just how complex these rovers are and how difficult it can be at times to get them working how you want them to, exactly when you want them to. This task, or this challenge rather, can be quite unforgiving at times, given that you have a small window to perform your task activities. The students in the team have built the rover from the ground up completely by themselves, designed, built, tested, integrated, written thousands of lines of code, no doubt. So we wish them all the best to try and get their rover operating before the end of the time. They've just got under 14 minutes left. So there's just gone 10 minutes left for UTS in the space resources task. And it looks like they have gotten drive control. You can see them filing into the base station there. When they've given the call, that door will close, they will be sealed off, and then the rover can begin the space resources task. So the UTS team has started the task and they're making their way off the lander now. They've just earned the first 5 points for this task, which is getting all 4 of those wheels off the lander, and they're making their way over to our simulated crater where our 3 sample sites are. You can see the UTS rover, because their wheels don't actuate, are using a method called skid steering to be able to turn. So if they want to turn one way, they just make the wheels on each side of the rover turn in opposite directions. While it's quite effective at turning, it can be challenging at times because the simulated lunar regolith that we've got is so fine and light that the wheels do dig in and create a bit of a divot. So they're approaching sample site number 2 there, where they'll be able to get some points if they're able to see that sample site on their base station computers and show the base station judge that they are within reach of it. So it looks like they might be happy with sample site number 2. So you can see on the right hand side of the screen there was 5 points available for descending the lunar ramp, which they've already achieved. 30 points for identification, which is broken down into 10 points each for each of the 3 sample sites. So they get those points if they're able to show the base station judge that they can see that sample site through their cameras on the rover. So without knowing exactly what the judge and the base station have seen, I would guess that they have scored 20 of those points from sample site 2 and 1, and they're just going for the 3rd sample site now. After identification, there's 40 points available for processing. That is, the rover is able to pick up or excavate lunar regolith from the sample site it thinks has the most water content and process it to try and get liquid water out of it. And then lastly, there's 25 points available for a presentation that the teams will do to our specialist judge in their base station tent at the conclusion of the task, making a total of 100 points for the space resources task. So the team has just under 4 minutes left. And it looks like they're trying their hardest to go and image that third sample site. So the team has called an intervention here. So that means that they're able to send someone out to the rover to try and debug a potential problem that they've had. They've got 3 minutes left. They will lose 10% of the points that they obtain. But if they can get it done in time, it means they'll have the opportunity to sample that third site. It looks like they've done the age-old trick of turning it off and on again. And let's hope that that's worked to solve their communications issue and they can get back underway and get those final 10 points for the identification section of the task. If you at home face similar issues and you want to sound a little bit smarter, instead of saying turn it off and on again, you can call it power cycling. Just makes you sound a little bit like you know what you're talking about a little bit more. If it works here, it should work for you. I'm sure that base station team is working frantically with 30 seconds to go to re-establish that connection and see if they can inch forward just to get those final 10 points of the identification portion of this task. Due to a delay, we're giving the team 1 more minute to try and complete that section of the task. Who's responsible for calling the time here? Sorry, I meant to switch channel to talk to the judges. So that's the end of the task for UTS. Let's give them a round of applause. They were able to score just over 20 points by descending off the lander and sampling a couple of those sites. So that was the UTS Rover team competing in the Space Resources task. They're a team from the University of Technology, Sydney, from Sydney, Australia. And these are preliminary scores because their score for the Space Resources Challenge has not been entered just yet. They received 65% of the score for the CDR and SAR submissions, and a few other points to make it to their total score of 69.5 at the end of day 2. Their score for the iSpace Space Resources task will be entered shortly. Coming up next, starting in a few minutes, we have UQ Space from the University of Queensland, from Brisbane, Australia, and they'll be competing in the Space Resources task. Their current score at the end of day 2 was 86, and they will be competing for 100 competition points in this iSpace Space Resources task. So UQ Space will be starting the Space Resources task very soon, where there's 100 points available. The judges and the team are just preparing the samples now before they get underway. You can see UQ Space's base station team. So they've got just 3 members in the team. They're one of the lighter contingents here at the competition. And they'll be running their custom software on their laptops to operate their rover today. This is a good shot of the UQ rover there. You can see they've got a double bogey suspension system, which has commonly been used by rovers on Mars and offers good articulation of the wheels so that all 6 of them remain in contact with the surface at all time. So UQ Space have started the task with a bang. They've scored themselves the first 5 points for descending off the lander. I've spoken with the team and they're using a new strategy today. After in the first 2 days they had a bit of trouble getting bogged in this really loose sand. So they are going pretty quick. So it looks like the UQ Rover has already scored its first 5 points for descending off the lander. There are then 30 points available for navigating to and identifying each of the 3 sample sites we have laid out on the field there. It appears as though they may have gotten site number 1 already, and now they're lining up to image site number 2. To get 10 points for each sample site, the base station team need to show the base station judge that they can clearly see the sample that has been placed in the ground there. Those 3 samples have different quantities of water in them, ranging from no water up to an unknown value. And once they've determined which sample might have the highest quantity of water, they're then responsible for excavating from that sample and trying to process it to get liquid water. And there's 40 points available for that. The last 25 points for the task can then be achieved by completing a presentation to one of our judges after the task has concluded. So extending from the front right-hand side of the rover there, as we're looking at it on the camera view, it looks like they've got some sort of probe which they might be able to stick into the surface and try and determine an accurate water quantity reading from. I'll be joined by a member of the UQ Rover team shortly to try and find out some more information about that sensor and about their approach to the task. So while there are 30 points available for identifying which side is which, the teams are able to score a few more points if they're able to determine an accurate reading for what that water quantity is in that sample, which they then relay to our judges in the presentation after the task. We might get that camera on us for a little bit, if that's okay with you. You can use a little bit to your left. Oh dear. So it looks like the rover might be going with that probe into another sample site to try and get another one of those accurate water readings, which will earn them more points. I'm joined by James from the UQ Space team, and he's going to tell us a little bit more about the rover and their approach to this task. But first of all, what degree are you currently studying, and what's your role on the team?
So my name's James. I'm the Administrative Director of UQ Space and the 2IC of the team. I'm studying a dual degree in Mechanical and Aerospace Engineering Honours and Physics, which means I spend more than 5 years at university, which is very cool.
Yeah, I mean, no worries. I spent 6.5 years at university doing my undergraduate degree, so it doesn't matter how long it takes to do it, mate. As long as you get those degrees at the end of the day, you're pretty set. Yeah, so can you tell me a little bit about the rover? Like I mentioned before, I think there is a water sensor on the front. Can you tell me if that's correct and what you're trying to do with that?
Yep, absolutely correct. So at the rear of the rover, we've got our soil sampling module and the moisture sensing module, basically mounted on a motor with a linear actuator, so we can rotate and stick quite nicely into the ground. And just by measuring the resistance across two electrodes, we can quite effectively determine the resistance of the terrain, and from that infer the water content based on some calibration we've done.
Yeah, awesome. So, yeah, essentially you're trying to pass electricity through the soil itself, and based on how difficult that is, that'll give you an idea of how much water is in there.
Yes, that's correct.
Cool. Awesome. Very, very cool. So it looks like the rover might be sticking that probe into sample number 2 right now. It's just lifted it back up by the looks of it. It might be having to move forward to get that alignment perfectly right. Before it can put the probe in that sample and get that water reading. So as the competition organisers, we've purposely not told you exactly what the concentrations of the water might be in these samples. But like everything in the challenge, we're trying to replicate the lunar surface and what you might expect there. So based on that, I'm interested here, you said you calibrated that sensor with some of your own measurements. How did you decide what measurements to go for, and what measurements did you go for, if you don't mind me asking?
Yeah, that's a really good question. So we started with looking at the amount of water content that we'd expect to see, like kind of at peak on the moon, and that was about 8% by mass was the absolute maximum we would expect. We then calibrated higher up to about 30%, I think, anticipating that maybe the competition makes it a little bit easier, and not quite the distinction between 5 and 8%, and go between 10 and 20%, perhaps. Yeah.
Yeah, awesome. And I think that, again, geology, unfortunately, is not my background. I do know a little bit about the moon, but I think there is some solid water ice potentially. There have been a couple of lunar orbiters. The Lunar Reconnaissance Orbiter, or LRO, is in orbit around the moon and has imaged the moon in quite a lot of detail. And it suggests that there might be some solid water ice on the moon. However, we haven't sent anything to explicitly explore those areas. And I guess that's the essence of this task and what will happen in the future. So, like I've mentioned before, there's 40 points available in the task for processing, which is after figuring out which sample has the most water, excavating that, digging it up, bringing it into the rover, and then processing it to try and get as much water, liquid water, as possible out of it. For reasons out of your control, unfortunately, you haven't been able to include that payload, I believe, on your rover today. If it were on there, can you describe very briefly what your approach was and how that might work?
Yep, absolutely. So we would use a similar tool to our excavation task to collect some dirt, pour it into a hopper, that then funnels down into a piston chamber, basically. Inside that chamber, there were 4 3D printer heating cartridges to heat up the inside of that container to above 100 degrees, effectively, to very effectively melt the ice. And then a piston on top simply pushes down through a linear actuator and extrudes water through some filter paper to get nice clean water, theoretically, out the bottom in a little container.
Perfect. Awesome. Good to hear. So it looks like the rover may have had a dip at sample 2, and it might be going to the third and final sample to dip its probe in and get a final reading there. So you can see the UQ space operators there. So they're using their computers in the base station to control the rover remotely. The feeds from those computers then go out to their antenna, which is then beamed to the rover itself and result in rover commands. So James, while I've got you, it looks like the rover has 2 small little black sticks on the back of it. I imagine that's something to do with the communication system. Can you tell me a little bit more about that and how the rover gets the signals that it needs to drive and operate?
Yeah, absolutely. So we're operating on about, similar to a Bluetooth frequency, I believe, to those 2 black sticks, those 2 antennas. And those antennas are responsible for all the drive and operational commands of the rover. So telling the wheels to turn and how they turn, telling them to deploy that soil sampler. That's all controlled by Nick in the base station, pushing buttons on his laptop, coming through the network cable to the antenna we've got mounted there, and then going straight across to the rover. The 2 white antennas sticking up as well, there's 2 big white sticks. That's for our camera system. So we've got those 2 antennas. We're actually 4 times stronger with our connections today than we were yesterday, because that was a problem we encountered. And we've got 4 cameras on the rover looking forward, back, down from up high, and then another one directly mounted to the soil sampler, so we can see everything that's going on. Also, the people in the base station can see everything that's going on, I should say.
Yeah, awesome. So, yeah, it sounds like you have quite a few cameras on there, pointing in all different directions. it's quite easy from out here to sort of see exactly where the rover needs to go if it's not lined up and that sort of thing. I don't know if you have been in the base station for any tasks this year, but if you are familiar with the testing or anything, can you describe just how hard it can be to locate yourself and where you need to be whilst those base station controllers are controlling the rover?
Absolutely. It's very difficult. You kind of think of it like driving a car in a video game or something, where of course you've got a camera set outside and you can see the environment and everything, but when you're just looking straight ahead, we drive off the land and we go, well, where are the imaging sites? Do we have to drive around and see everything? So that's where that camera on top really comes in handy, because we get a nice view of a fair amount of the terrain from the start, and then we can more adequately navigate to drive to where we need to be.
Cool. That's a good solution. And we've seen the good thing about the Rover Challenge, having so many different teams here, all facing similar problems, which might seem trivial at first, but it is hard to navigate and see where you need to go, and seeing a range of different solutions. So we've got that one camera mounted up high. I've seen some teams with a 360 camera. There's other teams which have cameras which can pivot and tilt so they can exactly look around without exactly moving the rover, because that's a lot easier than having to maneuver around and that sort of thing. So James, you were here last year at the second Rover Challenge. I'm interested to know how you think the challenge has evolved. Are the tasks harder, easier? How have you approached it differently? Did you learn a lot after the first one and have applied that to this challenge? How have you found it?
It's been really fantastic. I think certainly the challenges are a little bit more diverse and perhaps a little bit more demanding this year, it is quite exciting. Being able to, for example, construct a lunar road is something that maybe we'll have to be doing in the next 10 or 20, 30 years. So being able to work on that at this level has been pretty fun. Yeah,
10, 20, 30. I would say even maybe the next 3 or 4.
I sure hope so.
Who knows? Who knows? It could be much sooner than we think. Like there's tons of, I'd call those foundational services that are happening right now and need to happen soon to support the Artemis missions and humans returning to the moon. Sorry, I interrupted you. Go right ahead. Yeah, what else
absolutely.
have you learned and brought to this year's competition?
So certainly learned a lot about our own suspension system. So we've got that 6-wheeled rocker bogie. We actually had it on the other way last year and found that didn't work quite so well. So we've remade it with much tighter tolerances, and it generally fits together much better, and swapped it around so it can climb over obstacles much more easily. We were expecting to be able to climb into the crater again like we did last year, but having that nice channel in makes that a lot easier. But we were pretty proud that we could scamper over the lip of the crater all the way in last year.
Yeah, absolutely. So for those at home, last year there was a little bit more of a ramp into the crater to simulate it, what you might expect on the lunar surface a little bit more. The interesting thing about the lunar surface is because there is no atmosphere, there is cosmic radiation, cosmic rays, obviously no natural life on there, everything is completely preserved. If a meteor struck an area 20,000 years ago, it's likely that impact crater might still be there and form a perfect circle. So there's no free lunch, no easy road into the crater like there is at the Australian Rover Challenge.
Having the debris removal part through that canyon there as well was a different aspect, because certainly last year we just had a big scoop that would kind of come along and much wider than the rover and collect any debris in one go. But having to fit inside a narrower canyon that's really not much wider than the rover was another design challenge that we had to face.
Cool. And yeah, as designing the challenge, we want to try and simulate those tasks that you might actually do on the moon. And so if there has been an accident, hopefully not, but if there has, then maybe clearing up debris might be something that a rover definitely has to do. Like maybe there could still be a danger to life if there is life on the moon, and so you'd much prefer a rover to go out, which is a little bit more expendable than a life, and go clean up the mess.
from a set that I try to keep together.
And that no one's going to pick it up in the next 15 minutes.
Correct.
I'll forward it. Let's see what we'll take it.
Sure. Thank you.
Actually, what size is it?
It's just 2.5.
Maybe I'll take it. No, I'm kidding.
2.5. Oh,
Yeah.
that's a good one.
Where have you seen it so much from?
M3 is good.
Yeah.
It's the one that
Have you
always.
seen their bloody files, mate? Yeah, they probably tuned for 2.5 as well.
What was it?
Oh, it was
Was
all
it
the
the acrylic ones?
yeah, the black ones with the purple.
But weren't they like tied together with string?
Yeah, but the string was clamped up with bolts.
Oh, okay.
So 1,300 baskets.
Well, I definitely took it out over here, but I don't know if somebody's taken it since.
So on the feed there, it looks like the rover is going for a second dig at that sample site number 2. You can see it, the linear actuator there is on, and it is driving that probe into the sample. So like we described earlier, that would be trying to see what electric potential or resistance is between those two probes. And using the calibration that the UQ team has done, you can figure out what the water content in that sample might be. So it's interesting that they've gone back. We described earlier that they unfortunately don't have the capability right now to excavate or process the regolith. But James, do you know what might be the reasons why they are going back for a second time?
I can't say for sure because we can't communicate with the base team, of course, but potentially just getting a second data point. Maybe it was very similar to another site and they just want to go back and clarify, is it actually very close, or have we sampled just the top bit and gotten too much moisture from the air in that sensor, or getting a bit, I see they're digging in a little bit further than they did the last time, I think, so might be trying to go a little deeper and fully immerse that sensor in the terrain.
Awesome. Well, best of luck to them. Hopefully they get an accurate reading and score some big points in the presentation where they have to go through what those concentrations are.
Yeah, absolutely. I'm feeling pretty good looking at it go there.
Yeah, awesome. Like it appears as though everything has been going well. Like, yeah, have there been any other surprises that you guys have had today or in the other days?
Today's been pretty textbook, I think. Certainly the last few days. Typically we drive with 6 driven motors, all 6 of our wheels are powered. A couple of days before the competition, 2 of our motors failed. So we're operating currently on 4 motors, which is obviously a lot less power, and we've had a fair amount of trouble getting bogged at the start of the last 2 challenges. But we've changed the weight distribution a little bit, changed our software a little bit to run the motors a little bit more effectively, done a lot of testing in the time we've had in the evenings and early in the mornings, and obviously going much nicer on the terrain today, which is pretty exciting.
Yeah, that's it. That's a good story. Test, right? Like, I guess that's what engineers typically do, problem solve. And you came up against that bogging issue in the previous 2 days, and it sounds like you've implemented a range of solutions to try and overcome that. So that's great to hear. And like you said, great to see that the Rover is doing a lot better, driving through that regolith seemingly with ease today.
Yeah, absolutely. It's looking much like it was last year now, climbing over those hills and getting across that powdery sand, which is really very exciting. Yeah.
Yeah, I bet it must feel pretty good.
Oh, absolutely. It was pretty discouraging when it gets stuck a meter in front of the lander for 40 minutes, 2 days in a row, but it's looking good. Yeah.
Yeah, it'd certainly be a shame if you did send a rover to the moon and you were operating it and it got bogged as soon as it got off the lander. So glad to hear that you were able to troubleshoot and sort that out. And like I said, be performing a lot better today. So yeah, congratulations.
Thank you very much. I love the shots. We can't see anyone else or anything else. Really.
So if you tuned in at the start of this task, you may have seen that the rover was waiting on the lander for a little bit, just to make sure that it had enough, it was completely ready to start the task. They were in fact waiting for the field to be ready for it to compete. So it was not the rover waiting, they were waiting on the challenge judges. So we are electing them to give them 3 extra minutes compared to what you can see in the time remaining in the top right-hand corner. So we've just adjusted that now. So there is just over 11 minutes to go. So we'll see that count down until the end of their task. In the base station now, you're with UQ.
Yeah.
That's the second one.
Do they need it?
No, it's off. It should be off. Sorry, can you please repeat that? Better luck next time. Really good. So the UQ team has 10 minutes left here. You can see one of the sample sites. I believe it's sample site number 1, just under the rover there. So it looks like they've stuck that water probe in a couple of times to try and get that accurate water measurement. So coming up a little bit after 12:15, we'll have Project Scorpio entering the field and competing. That is Project Scorpio from Poland. So they'll be competing in the space resources task just after 12:15. So James, it looks like the time is rapidly expiring for UQ in the iSpace Space Resources task. All the teams will be competing in mapping and autonomous tomorrow. Can you describe what your approach is there and what you're looking forward to tomorrow?
So the approach at this stage is spend the rest of this afternoon optimizing on code to more effectively detect the AR tags and the colored cubes. And then, like I say, we'll just send down the ramp, drive around, try and find those points. We're pretty confident we can traverse the terrain really easily now, which has been our main challenge. So feeling good about tomorrow, yeah.
Awesome, that's cool to hear. Just-in-time delivery, I like the way you work. I'm sure you have lots of time this afternoon and probably will be working into the wee hours tonight to try and get that working and maximize however many challenge points you can.
We may well be. I'll hope not, but we'll see.
Thank you so much for joining me today, James. Best of luck for the end of the task, and if you are taking part in the presentation, best of luck for that. And then also best of luck for all the work that's yet to come this afternoon and tonight, leading into tomorrow's final task.
Thanks, Henry.
So there's just over 5 minutes left in UQ Space's attempt at the iSpace Space Resources task at the Australian Rover Challenge. And it looks like they are sticking that probe, their water probe, into sample site number 3 another time to get the most accurate reading that they possibly can. Without having the final confirmation, I would guess that they are sitting on about 35 points right now, after receiving 5 points for descending off the lander, and then 30 points for navigating to and imaging each of the 3 sample sites. By sticking that probe in to each of the samples, which they're doing right now in sample number 3, they are hoping to get a very accurate reading of the water content in each of those sample sites, which they will then be able to present to the judges in the presentation which will be occurring after the conclusion of the task. That presentation will make up the final 25 points which is available for this task. After UQ finish this task, we have Project Scorpio from Poland waiting in the wings, ready to go at their attempt at the iSpace Space Resources task. As soon as UQ finish, the field is reset. They'll be off and running just a little bit after 12:15 Adelaide time. just been notified that the UQ team are electing to end their task now. They've maximised the points that they're able to get with their current setup, so they're going to jump out here and take their rover off the field.
Australia is a nation of creators, aviators, protectors and innovators. From aviation's first light to the dawn of the jet age and beyond, at Boeing, we're building the future together here in Australia. Inspiring those in pursuit of new frontiers, connecting, protecting and exploring our region and the world. Home to the broadest aerospace portfolio in Australian industry, powered by talented, dedicated and diverse teammates. Delivering manufacturing excellence, building composite aircraft parts for the world's most efficient airplanes, using advanced robotics, materials and digital technologies. Never compromising on safety or quality, always focused on sustainability. Solving tomorrow's problems today with Australia's leading researchers, scientists and universities. Developing new military platforms and communications networks and helping ensure they are always mission ready. Keeping customers airborne by providing the services they require. We stand shoulder to shoulder with Australians during natural disasters, on the front line and in peacetime. We support veterans and our community, and we nurture the next generation of aviators to excite, to be bold. Boeing Australia. Made in Australia, by Australians, for the world.
Okay, are you ready? The first university to admit women, 2 Nobel Prizes, then another, then a couple more, 12 knighthoods, 22 Olympians, a pack of COVID-sniffing canines, Australia's first female Prime Minister. Finally, treatments for diseases and other scary things. The first female Queen's Counsel, Supreme Court Judge and State Governor, all in one. First in the family with a degree, a black belt, a robot. First Aussie to walk in space. Helped detect gravitational waves. Made lots of babies. World top 100 in all this stuff. launched a satellite, revived lost languages, home to 1600 brainiacs, and a winery, all in the heart of Australia's most livable city. So, what's next? Make history at the University of Adelaide.
Hi everyone, my name is Henry and welcome to the third day of the the Australian Rover Challenge. Today all the teams will be competing in the iSpace Space Resources task, and we are standing by for the start of Project Scorpio from Poland, who are about to commence the task. Their rover is up on the lander here, it's almost ready to go, and we are waiting final confirmation from their base station team and their judges before they get underway. The iSpace Space Resources task makes up 100 total points for the Australian Rover Challenge. 5 points is available for the rover to descend off the lander ramp there. There is 30 points available for identifying the 3 sample sites that we have placed out on the challenge arena. There are then 40 points for processing one of those sample sites and getting liquid water from it. And then there are final 25 points available for a presentation that the team will give to the judges at the conclusion of their field time. Project Scorpio are currently sitting in second place in the Australian Rover Challenge. They currently have a score of 191.4 at the end of yesterday's tasking. You're okay. And they've just scored themselves 5 points for this task for descending that lander ramp, and away they go. They'll be heading straight for the simulated crater that we've set up on the course where our 3 sample sites are located. Once they get there, if the team in the base station, that is the team who are remote operating the rover right now from a tent out of sight, you can see them on screen there. If they are able to show the judge in that tent that they are able to see clearly each of those 3 sample sites, they will receive those 30 identification points. 40 points are available for getting the most amount of liquid water. So each of the sites has a known quantity of water in them, simulating different areas on the moon that you might expect. The team has 40 minutes for this task, and they are wasting no time, having traversed very quickly to a couple of those first sample sites. And they'll be checking as hard as they can to see which one is going to bear the most water for them. How's it all going? Dave gave me that. Yeah, he made it into a sticker. Probably printer? No, I can acrylic printer and shit. We'll give you one. Where's it around? So without knowing the exact scoring from the commentary desk, I would predict that they've already scored 25 points, having navigated to and imaged sample sites 1 and 2. Looks like they're just heading over to sample site 3 now to try and get those final points before they might start to think about making a determination of where they'll be able to find the most water. So you can see, as opposed to Monash Nova Rover this morning, who had a dedicated science payload that would descend from the rover and excavate some of the sample, Scorpio are making use of their robotic arm with a different attachment to collect that regolith. You can see in this shot just how complex that wrist mechanism for their robotic arm is. That mechanism allows the arm to be able to orient that wrist and also rotate that end scoop through 360 degrees. It looks like they might have some sort of sensor on the bottom of that wrist, which they are orienting and potentially even sticking in that sample to make a determination of what the water content might be. So it looks like Scorpio is spending quite a bit of time over at sample site 3 there. Looks like they might be trying to excavate some of the top level of that sample. You can see they've got a bucket or a scoop on the front of their robotic arm there, and also a little drill potentially to break up the regolith. We've put these sample sites in the crater in what might be permanently shadowed regions, i.e. PSRs, on the lunar surface. You'll find these around the South Pole and the North Pole, around the poles. And they're areas which never receive any sunlight at all, so they're extremely cold. As a result, if there is any water content in those PSRs, it is likely to be frozen and very, very hard. So that's why they've got this drill piece, which they're just lighting up over the sample now, to hopefully break it up a little bit, which will allow their scoop to be able to get some more of the sample than by just scooping. So they've placed that drill bit on top of the sample now, and have started that to break it up a little bit. These types of challenges are exactly what NASA and other organizations are going to face on the moon. The amount of force that it would require to drill into how tough and hard that frozen regolith may be will require a lot of specialist engineering. It looks like they're going for another drill into sample site 2, try and break that one up a little bit and see if they can get any purchase with the scoop. So it looks like Scorpio have activated that drill once again for sample site 1. They're likely doing this to break up the top surface of that regolith, which will give them a better indication of how much water might be present. These samples have been frozen for 2 days in our freezer here to try and simulate exactly how hard and frozen they would be in the permanently shadowed regions at the poles of the moon. Scorpio are the team joining us here at the Australian Rover Challenge who have been in existence for the longest. They've competed at numerous competitions throughout the years in the last over a decade in Europe, in the United States, and other countries as well. We found out the news just a couple of days ago that they have been accepted into the University Rover Challenge for 2023, which will be happening in Utah in May and June. So we hope that the Australian Rover Challenge has given them a fantastic practice or warm-up for that event. And we wish them every success at the University Rover Challenge later this year. There are a total of 100 points available for this task, and the team has 40 minutes to complete it. So they're 15 minutes in, they've got 25 minutes left, and I would give them an unofficial score of about 35 points. That's 5 points for descending off the lander, and then 30 points for imaging each of the 3 sample sites that we've laid out there. There are further 40 points available for processing at those sites and obtaining liquid water. The team seems to be making great use of their drill bit, which is attached to the robotic arm on their rover, to break up the really tough soil in those samples, which has been frozen for 2 days. Once they break that up and can get an accurate determination of how much water they think may be present in each of those samples, they'll then have the opportunity to excavate one of those samples and then process it on board for water, which is how they'll be able to get a slice of those next 40 points. So you can see on the screen there, they're using that drill bit once again to break up that sample. And it's a great shot of the vision system that they have. That little silver horizontal bar is a depth perception camera by the looks of it. So it's got two cameras in one, spaced approximately the width that human eyes are apart. So this gives an operator, if they have access to a headset or some first-person goggles, it makes it easy to determine depth. When you are looking at a planar image on a screen, it is very difficult sometimes to figure out exactly how things are lined up, particularly forward and back instead of left and right is pretty easy. But in order to see how far forward or backwards something needs to be, having that depth perception is really, really important. So you can see it looks like the rover has a hopper on the front left of it, as we're seeing it right there, that little silver cylindrical canister. So I expect after they've broken up that soil a little bit and have found the site containing the most water, they'll be using that scoop to try and deposit some of that regolith into their hopper, which will then lead on to their processing process. You can see the Project Scorpio base station team there. And it looks like they've flipped over that bucket, just like a excavator would, to try and scrape the top and free some of that soil so they can scoop it up and put it in that hopper. We're just coming up to the halfway point of this task. 20 minutes has elapsed and they've got 20 minutes remaining. After this task, we'll take a break for lunch and we'll be back with the next lot of teams at about 2 o'clock. During that time, please feel free, if you are in the audience, to head over to Ingani Wardley, which is, if you're in the stands, on the left-hand side of the Challenge Arena, as we have the Australian Rover Challenge video game being presented in there, where you can drive the University of Adelaide Rover itself and compete in the Australian Rover Challenge on the moon itself. So please have a check that out. That is on the left-hand side of the Challenge Arena if you're viewing from the stands, next to the cafe which is open over there. So you can see here the base station teams. There's about 5-6 people in there. So they're tucked away behind the competition stands there. And all they've got at their disposal to navigate and operate the rover is the computers in front of them. So they're sending commands to their radio, which is stationed next to the stands, which is then being transmitted to the rover itself over a much smaller distance, of course, compared to the Earth to the Moon, which is then operating that rover. So I'm not sure if you can quite capture it on the screen there, but it looks like the Scorpio team is using some interesting tactics. They have lifted up the entire sample and looks like they might be trying to tip it on its head to empty it out. Let's see if it works for them. So it looks like the team has been successful in tipping this supply cache on its head, and they're trying to free the sample which is underneath. So this gives a great shot of the Scorpio robotic arm there. So typically we describe some of the joints of the robotic arm in a similar way that you would describe a human arm. So on the left-hand side of the screen there, you'd call that the shoulder joint, and you can see the motor turning, which would be turning a gearbox and driving that joint. In the middle, we've got the elbow joint, and then there's some complexity at the wrist, which we've seen previously. So they're still using that robotic arm to do as well as they can to get any of that sample free. Many of the teams here at the challenge make quite a large use of 3D printed parts. So you can see on that elbow joint, there's some orange and red pieces which are holding various components of the robotic arm together. Of course, there are some more structural pieces in different colors. So the silver pieces are in metal. I'd guess maybe an aluminium or a titanium for added strength, but not too much weight. And then the main linkages of the arm are those black, I'd guess, carbon fiber tubing for great strength and low weight. The Scorpio operators look pretty experienced, and they were able to deal with quite a lot of adversity yesterday when, unfortunately, during the debris clearing activity during the excavation and construction task, their end effector, i.e. the scoop that was on the front of their robotic arm, unfortunately failed and snapped off. They were then able to still score the remaining points in that activity, the debris clearing activity, by using the blunt end of what was left of the robotic arm to push the debris out of the marked area. It looks as though they're trying to use some of that similar ingenuity to get some of that regolith free from that supply cache. here. You don't have to turn it off, but if you're not talking, just hold it away maybe. And we'll go for it.
Yeah, sure.
Only a couple minutes, okay? There's only 7 minutes left. So it looks like the rover is still trying to clear some debris, or not clear debris, sorry, but trying to get some of the regolith out of that supply cache. So they're trying as hard as they can to get that sample. And I am joined by Sophie from Scorpio. And yeah, Sophie, what is your role on the team? And yeah.
I am the team leader currently, co-team leader with my friend who is currently in the base station, and mostly do marketing and finances in Scorpio right now.
Yeah, awesome. So, like I described earlier, you guys had a bit of an unexpected breakage in the robotic arm yesterday. Can you describe exactly what happened and what have you and the team been busy doing in the last 16 hours or so to get the rover ready for the space resources task?
Actually, we just broke some 3D printed parts that would connect our manipulator to the rest of the arm, and we just had to print them out, put them back together, but the place where they're placed actually makes it very difficult, so it was like at least our job to do that, and then we had to transfer the rover for the scientific task today.
Awesome, yeah. So a bit of a long night trying to get that fixed. Like you said, 2 hours just to replace that component. Obviously wasn't very easy. Everyone was working hard, I'm sure.
Yeah, everyone was working hard, and actually some of the guys ended the task at, I think, 6:30 in the morning today. So they went to sleep at 6:30, and 7 o'clock was our wake-up time, so it was a long night.
Wow, okay. They've been working extremely hard to get the rover ready, and it's doing fantastically in the task today. So that's fantastic to hear. Yeah, so it's interesting that so you obviously brought some 3D printers over from Poland, which means that you can just manufacture some pieces if they break or if you need new ones. How good is that flexibility?
We actually find out that the 3D printer is essential at the competition because something every time can break. So the 3D printer is the minimal that we take with us. So obviously with the plane we couldn't take anything larger, so we just took the small home 3D printer, but it's just enough for us. If we need, we know the other teams were ready to help us after what happened yesterday. So we're quite happy that it was just, I think, 3 3D printed parts that broke and some electronics to fix.
Cool, awesome, yeah. I guess 3D printing technology has come so far in 10 years or so, maybe a little bit more, that I think all of the teams here probably have a couple in their workshops, and so you can just so easily design a quick part, put it onto print, and in a couple of hours it'll be done and you can smack it on the rover. So that's really cool. Yeah, and like you said, you brought obviously everything over in suitcases from Poland, so you're up against it compared to the Australian teams, but you guys have been performing really well, currently in second place. Yeah, what are you looking forward to tomorrow in the mapping and autonomous task? Will the team have to have another big night tonight to get ready for that?
Actually, you can test autonomous drive during the night. You can just test it during the day, so it's not going to be long night, we hope, at least. We'll just take off the manipulator because it's not needed for the autonomous task. We'll just leave the not essential stuff. And I think that's all. We are mostly ready for the autonomous task, at least something changes last minute. And then we'll just test the software until the sun comes down today.
Perfect, awesome. Well, best of luck for that, and best of luck for the mapping and autonomous task tomorrow. I'm sure you guys will do fantastically. And yeah, thank you for speaking with me, and thank you to you and the team for joining us at the Australian Rover Challenge, the first international team. We're really thankful to have you here, and yeah, make it more of a competition and give the Australian teams a bit of a run for their money. So I hope you can get some good sleep tonight, and the rest of the team can, and you'll be raring to go for the last task tomorrow.
Thank you. Good to be here. Never again.
So it looks like the team is back at sample site number 3, and they've got that drill back out to try and free up some of that regolith on the top of that supply there. They've got just over 2 minutes left, so we'll wish them the best of luck to see if they can get any of that regolith into their rover and potentially process some for water. They really are exhausting all of their options here to try and get some of that regolith and score maximum points. With just 1 minute left, let's see what they can do. I'm sure there are some quick fingers working in that base station to try and punch in those commands. The bucket is going in. Let's see if it can excavate. That is the end of the task. Give them a round of applause.
You going back? The rover is going back by itself, or you want us?
So that was Project Scorpio competing in the iSpace Space Resources Challenge. They're a team from Poland, and their total score is 191.4 after 2 days. After this task, the score will be tallied. They will soon do their space resources presentation. Looks like the rover is taking itself back to the start. This is not for competition points, but it's just something that they're interested in doing. We've got the current leaderboard up on the screen there. So this is incomplete from day 3, from today. So there are some scores which have been added from some day 3 tasks and some which are yet to. So the top 3, currently in 3rd place, we've got the Unimel Rover team. In 2nd place, we've got Project Scorpio, who just competed. And in 1st place, we have Monash Nova Rover. So we will work to update this and have a more accurate leaderboard shortly after lunch. We'll be taking a short break. We'll be back with the next team starting at 2 o'clock.
Thank you.
Australia is a nation of creators, aviators, protectors and innovators. From aviation's first light to the dawn of the jet age and beyond, at Boeing, we're building the future together here in Australia. Inspiring those in pursuit of new frontiers, connecting, protecting and exploring our region and the world. Home to the broadest aerospace portfolio in Australian industry, powered by talented, dedicated and diverse teammates. Delivering manufacturing excellence, building composite aircraft parts for the world's most efficient airplanes, using advanced robotics, materials and digital technologies. Never compromising on safety or quality, always focused on sustainability. Solving tomorrow's problems today with Australia's leading researchers, scientists and universities. Developing new military platforms and communications networks and helping ensure they are always mission ready. Keeping customers airborne by providing the services they require. We stand shoulder to shoulder with Australians during natural disasters, on the front line and in peacetime. We support veterans and our community, and we nurture the next generation of aviators to excite, to be bold. Boeing Australia. Made in Australia, by Australians, for the world.
Okay, are you ready? The first university to admit women, 2 Nobel Prizes, then another, then a couple more, 12 knighthoods, 22 Olympians, a pack of COVID-sniffing canines, Australia's first female Prime Minister. Finally, treatments for diseases and other scary things, the first female Queen's Counsel, Supreme Court Judge and State Governor, all in one, first in the family with a degree, a black belt, a robot. First Aussie to walk in space, helped detect gravitational waves, made lots of babies, world top 100 in all this stuff. Launched a satellite, revived lost languages, home to 1,600 brainiacs, and a winery, all in the heart of Australia's most livable city. So, what's next? Make history at the University of Adelaide.
Australia is a nation of creators, aviators, protectors and innovators. From aviation's first light to the dawn of the jet age and beyond, at Boeing, we're building the future together here in Australia. Inspiring those in pursuit of new frontiers, connecting, protecting and exploring our region and the world. Home to the broadest aerospace portfolio in Australian industry, powered by talented, dedicated and diverse teammates. Delivering manufacturing excellence, building composite aircraft parts for the world's most efficient airplanes, using advanced robotics, materials and digital technologies. Never compromising on safety or quality, always focused on sustainability. Solving tomorrow's problems today with Australia's leading researchers, scientists and universities. Developing new military platforms and communications networks and helping ensure they are always mission ready. Keeping customers airborne by providing the services they require. We stand shoulder to shoulder with Australians during natural disasters, on the front line and in peacetime. We support veterans and our community, and we nurture the next generation of aviators to excite, to be bold. Boeing Australia. Made in Australia by Australians for the world.
Okay, are you ready? The first university to admit women, 2 Nobel Prizes, then another, then a couple more, 12 knighthoods, 22 Olympians, a pack of COVID-sniffing canines, Australia's first female Prime Minister. Finally, treatments for diseases and other scary things, the first female Queen's Counsel, Supreme Court Judge and State Governor, all in one, first in the family with a degree, a black belt, a robot. First Aussie to walk in space, helped detect gravitational waves, made lots of babies, world top 100 in all this stuff. Launched a satellite, revived lost languages, home to 1,600 brainiacs, and a winery, all in the heart of Australia's most livable city. So, what's next? Make history at the University of Adelaide.
Hi everyone, welcome back to the third Australian Rover Challenge. This afternoon we have the 4 teams left to compete in the iSpace Space Resources task. The first one will be QUTRC Artemis from the Queensland University of Technology, or just QUT. They're hailing from Brisbane, Australia, and currently, after 2 days of competing, their score is 123.7. They'll be starting the task in a couple of minutes. We've not caught any sight of them yet, so I'm sure they're hard at work behind the scenes, readying their rover to make sure that they are ready to compete. You can see up on the leaderboard, they're currently sitting in 4th place, sitting behind Monash Nova Rover in 1st, Project Scorpio and Unimelb Rover team. These are preliminary scores. We have not entered all of the scores from this task from this morning, just because we need to tally them and make sure that the presentation scores are all up to date. The leaderboard will continue to fill out throughout the day, and we'll continue to show that to you so that you can see the up-to-date scores. The iSpace Space Resources task consists of a handful of activities for competition points. There's a total of 100 available points in the task, the first 5 of which you can get from going from the starting position, which is on top of the lander, onto the competition surface. The next 30 are then available for navigating and then identifying identifying the 3 sample sites that we have in our simulated lunar crater on the challenge surface. After that, the teams will have to determine which of the samples has the highest water concentration in it and then try and excavate that sample and process it to end up with some liquid water. Finally, there are 25 points available for their presentation, which they'll be conducting to one of our judges in their base station after the end of the task. So we are leaving no prisoners behind, and unfortunately their 40-minute task time has started. So we'll have that in the top right-hand side of your screen so you can see that. And so they'll be out here whenever they're ready. I'm sure they're busy behind the scenes readying their rover, making sure everything is ready. They'll carry it down here once they're ready, so sit tight. And in the meantime, we'll wish them the best of luck to get all that sorted. John's not actually saying anything because it's comfortable in the shot with his parameter. I will say stuff, yeah. I think step closer this way. When I come to this door. I think because the solar panel might be obscuring it a little bit. Here we go. Oh, go, quick, we're about to switch to us, yeah. Hi everyone, so we're still waiting for QUT to jump out of here. I'm sure they're working really, really hard behind the scenes. It is no easy feat even to get a rover on the lander and moving. That's why in real industry it takes decades, even longer. There are many, many moving parts. They've designed, built this thing all by themselves, and they're working super hard behind the scenes, and we hope to get it out here shortly and get moving. So we'll keep you updated. While we're waiting, for everyone joining us in person, feel free to head over to Ingarni Wardley, which is just on the left-hand side of the Challenge Arena. Inside there, we have the Australian Rover Challenge game, where you can control the University of Adelaide Rover in a simulated version of the competition. So it really is simulationception, because the competition is simulating the moon and the game is simulating the competition. It's really fun. I did go yesterday, so if you want to control the rover, head on in, and hopefully by the time you get it back out, QUT might be prepping their rover and ready to go.
Why?
I'm joined by Lachlan, who's a fellow competition organizer, just like myself. And he's going to tell me a little bit about himself and a little bit about his role. So Lachlan, what are you currently doing with your life?
What am I currently doing with my life? That is a great question. I'm a year into my PhD now, up at the Australian Institute of Machine Learning, just over in Lot 14. And the topic of my PhD broadly is AI for space robotics. So it links in pretty well with some of the work I'm doing here. I've done, over the last year, little bits of different bits and pieces, but at the moment focusing on how we can use craters on the moon for navigation for lunar satellites, which has been, really exciting.
Awesome. So I guess they must have to have some sort of imager so that you can see the craters in pretty good detail. Is that right? Like, what sort of resolution are we talking about?
Yeah, I mean, it all very much depends on the mission and how far away you are. But having some sort of camera to take pictures of the satellite, of the craters, and then figuring out, okay, well, from this picture, where are the craters in this image? Trying to, fit ellipses to the rims of those craters. And then from there being like, okay, well, if we have this picture and there's all these craters in this picture, and we know where a bunch of the craters are on the moon from lots of the previous missions that have gone up, how can we match where we know the craters are to where the craters are in our picture, and almost use that as kind of a fingerprint to figure out where the satellite must be?
Yeah, so I think I heard a stat, unverified, not fact-checked, but you can believe me if you would like to, that the moon is mapped to a greater level of detail than the bottom of the ocean. Have you heard that too?
I have heard that. Again, also not fact-checked, but I would very much believe that to be true.
Yeah, so I was thinking that, you must have to have a pretty good map for then to be able to be pointing at a few features, a few craters, and then from that information be able to tell where you are.
Yeah, so I mean, all sorts of people have been very interested in the craters on the moon for a very long time. A lot of the data we have is data that's been collected by and for geologists and planetary scientists and all those sorts of people that have been trying to figure out information about the history of the moon and what has happened to it through its life and all of that sort of stuff. And now as kind of engineers and computer scientists, we're coming in and making use of all of that data that they've collected for their scientific reasons and using that to help them do more science.
Cool. So is this technology something that could be applied to current spacecraft, or is it for future missions or future orbiters of the moon?
Yeah, so we're looking into it at the moment for a specific future mission that I don't know how much I'm allowed to talk about, but hopefully we will be...
A secret, unnamed
Yes.
future mission to the moon. Very exciting.
Yeah.
Cool. And tell me a little bit about your role on the organising committee of the Australian Rover Challenge. What have you been working on?
Yeah, so I've joined the organising committee of the challenge for the first time over these last 12 months since the last challenge. I was co-lead of the University of Adelaide team for the 2 years before that, but then finished up undergrad and was moving into my PhD and figured it was time to move on from that team, but still obviously wanted to be involved. And so yeah, this year I've had a lot of, especially oversight of kind of the rules and requirements and these long, boring documents that we send to the teams, and they spend months and months reading and then building a rover to match.
Or not reading.
Or not reading, as the case may be. And yeah, I also, given my sort of computer science background and the AI part of my PhD, have had a big part of overhauling the autonomous task, which is the task that the teams will be competing in tomorrow, where we're going to have a bunch of different markers scattered out across the lunar surface, and they have to either autonomously or still in a controlled way drive their rover around and try to give us a map of where all of those markers are to the greatest accuracy possible.
Yeah, so before Lachlan joined the committee, I had the unenviable task of writing the rules for the autonomous task, and very happy to say it is in a much, much better place now that Lachlan has jumped on board and overhauled it. So I'm very thankful for that. I'm sure the teams are very thankful for that, and I'm very excited to see what happens tomorrow in that task.
Yes.
I'm sure you're busy.
Could be interesting.
Could be interesting. That's exactly right. So that task will be tomorrow. Task times currently planned to start at 10 a.m. tomorrow. That's 10 a.m. Adelaide time. I'm sure you're busy. I'll let you run back to what you were doing. And yeah, thanks for chatting.
Lovely. Thank you, Henry.
Hi everyone. If you've just recently joined us, we are currently waiting for QUT to join us out on the field to commence their iSpace Space Resources task. So they've currently got 17 and a half minutes left of their task time, which they can use at any time to try and earn some competition points. And we're rooting for them behind the scenes to hope that they can get their rover in a position to bring it out here and compete. So you can just see there that they might be starting to set up their base station now. So I'm sure they're working really hard as quickly as they possibly can to get their rover out here and get some points. Looking forward, at about 2:45, we should have the Uni-Melb rover team commencing their task. That's 2:45 Adelaide time, which is in 22 minutes. So you can see the QUT team there frantically setting up their base station. I have received word that they might be shortly on their way. We're trying to see, I think that's them just on the weigh scale there. So before every task, every team has to weigh the current configuration of their rover to make sure it is within the weight limits. So for all tasks except the one that happened yesterday, that limit is 50 kilograms. So they're laughing. That might be because yesterday or the other day they were scraped in at 49.6 kilograms. So I hope they still have that small 400 gram allowance up their sleeve. And hopefully they'll be bringing it down at any point. As soon as you see them emerge from that tunnel, let's give them a round of applause and encourage them to get out there, get it set up as quickly as they can so that they can be on their way. So QUT are out here, they got their rover and they're just taking it up to the lander now. Hopefully they'll have enough time to earn some competition points. Let's hope that their communications establishment is as swift as possible and they can make their way down the lander for the first 5 points and potentially make it into the crater to go prospecting for the 3 sample sites that we have in there. So compared to the QUT rover configuration from previous days, you can see it's a little bit different for this task. So I can see that they've placed a big black cylinder type thing on the back of their rover, which appears to be part of their processing system. Someone was asking questions about their condenser yesterday, so I imagine that that is where they're going to be cooling potentially some evaporated liquid to then turn that into liquid water to submit to the judges. So you can see, even though QUT, this is the first year that QUT have competed in the Australian Rover Challenge, and they've come such a long way in such a short time. There's been other years where first-year teams haven't gotten as many points or haven't been as equipped to operate the way they have. One particularly impressive note is their base station setup. You can see in the top right-hand side of the screen, they have a big briefcase with a couple of screens and a couple of joysticks all built in, ready to go. Given that the teams only have 15 minutes to set up their rover and their base station, it's really essential that they have this process really tailored and they can do it in a really quick time. And so having that set up makes it super easy. So on the screen there, you can see on the back right-hand side of the rover, they've got a self-gimbling camera. So if we pan just a little bit up again. Beautiful, thank you. So the 3D printed red part there seems to hold that black camera, and then the purple 3D printed parts can rotate that in either direction. We spoke a couple of in previous tasks about how hard it is to perceive and sense your environment when all you've got is a couple of camera feeds, particularly depth perception. And so having that camera on that gimbal makes it a lot easier because instead of moving the rover around, you can just move the camera around. So a quick reminder, if the team are able to get underway today, there'll be 5 points available for descending off the ramp and onto the lunar surface, and then a further 30 points available for navigating to the sample sites that we have set out in the simulated crater in the far back right corner of the challenge arena as you view it from the stands. You can see on the screen there that QUT is another one of the teams who utilizes 3D printed wheels in 3 beautiful colors by the looks of it. I wonder if that was a design decision or a stock filament decision. It was a design decision. Awesome. So those wheels are probably printed in place on your typical plastic 3D printers, and I'd predict they probably take about 16 hours to print each. 18. Pretty close, not bad. So 3D printing technology has come quite a way in not a very long time, the past 10 or 15 years or so. So you can buy a $300-400 printer off the shelf, and it will be able to produce these wheels in whatever color you want, as long as you have the filament for it, in about 16 hours, which is pretty cool. It also means that if they break one during the competition, I assume they've brought a 3D printer with them, like most teams. They absolutely have. It just means that they can print a new one, just like that. So there's only 20 seconds left for the QUT team. Let's see if they can do it. Otherwise, during the break between QUT and Uni Melb, who are the next team to compete, we're going to bring you some live images from the Exteries lab here at the University of Adelaide, who have some small rovers of their own operating in their simulated lunar or Martian environment. And they're actually being controlled from Japan, from the Tokyo Dome, a theme park type thing which has any member of the general public can walk up and control a rover across the other side of the world. That's pretty cool. Some other news just in the meantime, the cafe across the road, on the left-hand side of the arena, will be closing at 3 p.m. So if you are hungry, or you need some food, or you need some beverages, please head over there before they close. And while you're there, there's also the Australian Rover Challenge game over next to the cafe, set up on those monitors there. You get the chance there to control the University of Adelaide Rover or build your own, and take part in a simulation of the Rover Challenge itself.
「このサブサーフェスにある程度水があるということが示唆されています。なので簡単に掘れる場所で水を探しましょう。
Irrespective of the result, can we get a round of applause for QUT? It's a lot of effort just to get here, and they've done a fantastic job and worked so hard to get to this point. These sorts of things happen. There's one more task tomorrow, and let's hope that they can debug whatever's happened and get their rover moving then. put up their full card or just leave it like this? Oh. You were aware of the wrong card? Cool, thank you. So next up for the iSpace Space Resources task, we have the UniMelb Rover team from the University of Melbourne. In which city? You guessed it, Melbourne. Their total score at the end of day 2 is 147.4, consisting of the breakdown that you see there. There are 2 more tasks left, the iSpace Space Resources task, which is happening right now, as well as the Boeing Mapping and Autonomous task, which will be happening tomorrow. There are 100 points available for this task, 5 points available for descending down the lander onto the challenge surface, 30 points available for navigating to our sample sites in the simulated crater, 40 points available for processing liquid water from those sample sites, and a final 25 points available for conducting a presentation with our judges to explain what the team found in the field. We have prepared 3 sample sites specifically for this task. So we have baked some sand to get all of the water out of it. We've then added a known quantity of water back to it, and then we've put them in the freezer for 2 days. So depending on the water content, there'll be a different level of hardness. They might look different, they might appear different. Their mechanical properties are definitely very different. And so the team's job is to go over there, figure out the differences between them, and then go ahead and excavate from the one they think bears the most water, and then process to get that liquid water. This is exactly the type of task that a rover will be performing on the moon soon. And water is essential for sustaining a human presence on the moon. As well as just using it for drinking water, it can also be used to manufacture some rocket propellants, which can then be used to return either some scientific stuff or humans back to Earth, or even go deeper into space beyond the Earth lunar system. So the UniMelb Rover team have indicated that they are ready to start the task. So we should be seeing their rover move off the lander at any point now. So there's 5 points for the UniMelb Rover team. And they're navigating over towards that crater which holds our 3 sample sites. The UniMelb Rover is in a nice shade of blue, red, and a little bit of white. I'm not sure where they got their inspiration from. That's a lie, I do. They've been inspired by Thomas the Tank Engine. It's not a lie. So you can see they've gone straight for sample site number 2, which is straight ahead after entering that crater, probably because it's easiest to maneuver to. And they're going to line up some sort of sensor above that sample site so that they can try and figure out if there might be some water hiding in there, and if so, how much. So after going to sample site 2, the rover made light work of heading over to sample site 1, and it looks like they're doing a full 180 to go and have a look at sample site number 3. So it looks like the rover might be a little held up at site number 3 there, without knowing exactly what's happened in the base station. To get the 10 points for imaging that site, the base station judge needs to be able to clearly see the sample and the number on the screen that the base station operators are looking at. To tell us a little bit more about the Uni Melbourne team, as well as their approach today, I'm joined by Jasper, who's a member of the team. So Jasper, can you tell me a little bit about your role on the team, how you got onto the team?
Sure. So I joined the electrical team about 6 to 9 months ago. I couldn't remember exactly. And I'm going to be moving into the coordination role this year. So electrical team member doing technical stuff and then moving into a more of a like management style thing this year.
Cool. So the coordination team, you said. So what would your roles and responsibilities be when you move on to that?
So specifically, I'm going to be looking after the business side of the team. So outreach as well as social media and building up the Rover's brand within the uni and then also externally as well.
Oh, awesome. A bit of a move away from the technical side of things, but very important nonetheless. Like the team obviously can't operate without that. It looks as though the Rover is going for a bit of a field trip. There are no competition points available over that side of the arena, but maybe they've gone to inspect the miracle of a grass outbreak on the moon. Ooh. So I'm going to put Jasper on the spot a little bit. We're not entirely sure what they may be doing. Can you hazard a guess at what they've done? They've just gone for a little bit of a drive. Like, what was the overall approach to this task before you started?
Sure. So our approach to this task initially was to send the lander and then make a beeline for the science area, inspect each site visually, and then do some extraction. I think in the spirit of the rover competition, we've decided to do some unplanned exploration. And I think now we're returning to our science mission now with somewhat limited success.
I did get a clarifying question from a judge just before that the team in the base station have asked whether they're allowed to drive over the sample. So I'm not exactly sure how that's going to fit in, whether they're planning to drive over it and then spin the wheels and flick it somewhere, but we'll wait and see. That front left wheel definitely is over that sample right now, and they seem to be driving over it quite a bit.
I've got two guesses for what our approach is here. One, we have lost some of the cameras on the front and we're trying to use the rear camera. And two, we're trying to make life difficult for you guys. I'm a fan of option 2, personally.
We are the people who decide how many points you get, so. No comment.
I have nothing to say about that.
So we've got some hands on the heads from inside the base station. Not really sure what they may be doing here, but we'll see how it works out for them.
It's definitely going to be an interesting debrief after this task.
That is an interesting topic. You said, so the team is going to debrief after this. Can you chat us through exactly like what your approach is to these competition days? So like start the morning, do you guys meet everyone is assigned some tasks to get the rover into the final state? So like how does a general day in the life of the Rover Challenge look like to you?
Sure. So the debrief is something that's happening for this task in particular because I'm going to have a chat with what they're doing. We don't officially debrief normally, but I think we might have to for this one. Generally, we've been kind of pretty free-flowing. We haven't got a specific structure of who needs to be where at what time. We try and keep the team as casual as possible. But obviously, you have certain key team members that need to be there as much as possible, or for specific tasks, specific team members need to be there. And so most people know where they're needed and get there pretty quickly, which is quite good on my side. On the coordination side, it makes my job a lot easier, which is good.
So you can see the base station members pointing at the screen there. They obviously see something they like the look of. If tipping over sample 2 was not enough, it looks like they're going for more with sample 1. Let's see how it works out for them, Jasper.
Maybe the exposed metal surfaces will make satellite detection of the samples easier.
Perhaps. So you mentioned before, and I've mentioned before, that there are 40 points available for processing, i.e. obtaining some liquid water from the samples. You have mentioned that for some specific reasons you might not be able to attempt that today. Can you chat us through what your original intentions were and what's happened that means that you can't do that right now?
Sure. So originally we had a very beautiful system devised to scoop some sand up, melt it, get the water out, and then a couple of things went wrong, so I tried to fix it with my electrical knowledge and made it considerably worse, and so we've had to scrap that attempt because things would have gone very wrong if we tried it.
Cool. I like to see that you guys are playing it safe, not doing anything too fast and loose. So that's good to see. But yeah, so did that all come together last minute? Do you have a specific team who's been working on that payload for a decent amount of time, or how does that all worked?
Sure. So yeah, we have a science team. I think we've been calling that based on the previous name of this task, and they've been working pretty hard on this system. But unfortunately, timelines have been pretty limited. So they've been able to test components individually, but we haven't been able to do a full integrated test on the rover. And so when we integrated it, it was unable to work, unfortunately.
Yeah, no worries. bit of laughter, it sounds, coming from the base station itself. And yeah, it is so tricky sort of working up to those full-scale integration type tests, like with all space type of hardware, because it needs to work, because unlike in the challenge, you can't just send an astronaut or anyone over to fix it once it's been launched. So often the teams will embark on this journey of component testing and then subsystem testing and then system testing and then fully integrated system testing. There's a lot of steps to get there.
Definitely, I think very large scale.
Yeah, awesome. It appears to be making some sort of noise. Do you know what that might be? Or am I thinking things?
No, I don't know what that might be.
So one of the awesome things about challenges like this, and what I've seen when I used to compete in challenges like this, is that they're so motivational to figure out what doesn't work, and people always come up with so many ideas about fixes whilst we're here, and they're just so motivated once they get back to their home city, home country, to then go and make those fixes and improve on the rover. Have you seen that in the first 2 days, that people have been sort of thinking bigger, thinking better, and just wanting to make fixes? And if so, what are a couple of things that or changes that you guys have already identified you want to make for the coming years?
Absolutely. One of my favourite parts of being in the team is just brainstorming and coming up with ideas of how we can make things better. I've been, when we get back to the hotel, been thinking about stuff all night of what we could have done better, what improvements we could make in the future. And so I think the whole team is looking forward to a bit of a break and then getting started on some of the ideas we've had over the last few days.
Yeah, awesome. Make sure you write them down. Otherwise, they can be easily forgotten. So they're just over halfway through the competition time. They've got just over 19 minutes left. And my educated guess would say that they're probably sitting around 35 points. So 5 points for descending off that lander, and then 30 points for imaging each of those 3 sample sites. A further 40 points are available for water extraction, and the last 25 come from the presentation that will happen in their base station with the judges after the task is finished.
I'm going to move the antenna to the antenna position because it's part of the antenna box. So it was in the briefing. Yeah. Could it go please back into the... Would you like me to move it? Yes. I'm happier for a team to move it. Sorry about that.
So it looks like the base station team are having a bit of a chat, probably deliberating exactly what they might do next. It's hard to exactly interpret what they're doing. We did consider putting microphones in the base station, but we thought that there'd be more garbage coming out of those than stuff that would add value.
I think that's a very good call. Okay. Maybe we're going to keep some in the tracks, and that's going to be our submission to you guys.
So if running over sample 1 and 2 was not enough, they've gone back to number 3 for more. Yeah, that could be an idea. One idea we had here is that potentially the water content of the soil might affect how the tread print turns up in the top of the sample. I'm not exactly sure what that...
I think we might have been more angling to exploit a loophole. So wouldn't give us too much credit there, mate.
There's nothing that judges like more than teams, what did you say? Exploiting a loophole.
I think that's the spirit of the competition to some extent. You've got to be creative to get to the moon or to get a rover on the moon. So you've got to be creative when you approach a competition as well.
Definitely, definitely. Okay. So it looks like this is part of the processing system, which would be used to collect the regolith. However, the linear actuator on the top is not allowing that processing facility to lower to the surface. We're not sure if the base station know that or not. So I've been told that from the first 5 teams to compete in this task today, no one has been able to extract any water, which just shows you just how difficult this task is. I imagine it's even 1,000 times harder if we were actually doing it on the moon. But what that means is that there are 40 points up for grabs for the team who can get any water out of that sample. So we've got 2 more teams to come today after the University of Melbourne. RMIT are on after the University of Melbourne, and they will be starting around 3:30. And then the University of Adelaide will be rounding out our day, beginning their task at about 4:15. Again, there's no challenge points available in this task for any activities outside of the crater. So I think the only explanation for this is a little bit of showing off or something. I'm not 100% sure. Are they going to go back on the lander? No. They're going to go, okay.
I think the one thing that's worked very well this competition is our drivetrain. So I think we're just flexing a little bit.
Yeah, definitely. It's cool to see from this back angle that that rocker plate at the back sort of actuate up and down on either side to accommodate for the left and right hand sides of the suspension. So they look to have lined up a rock. Again, some laughing coming from the base station there. There's been a suggestion that after seeing the green grass, maybe they're looking at the other rocks to see if there's more signs of life.
I think adaptability is a big part of lunar missions. You often, something goes wrong and you have to completely change your goals of your mission, so perhaps that's what happened here.
Yeah, that's exactly right. Cool story actually about the InSight mission on Mars. So that is a stationary lander that they had with no moving platforms or anything like that. One of the main missions for that was to investigate the seismic activity on Mars. So they had a payload called the Mole, which they dropped onto the surface, and its objective was to sort of dig down as far as it could, I think greater than 5-10 meters even. And so they were having a problem with their solar panels, being that they were getting covered in Martian dust and producing less power. So what they were able to do with their robotic arm was actually pick up some of the Martian regolith and dump it on the solar panels, which then sort of brushed some of the dust off, and they were able to increase their power output as a result. So like you said, Jasper, ingenuity, problem solving, all very important during a mission like this, and I'm sure the base station have thought of a very creative way to deliver more value to this specific mission. Maybe. No. So they are going back up the lander. Seems as though this rope. Oh!
I think the base station might just be trying to get my heart rate up a little bit.
So you can see the lower speed is probably delivering more torque to those wheels, which is enabling it to get up that steep lander ramp. There is quite a bit of regolith on top of the lander, which isn't helping in terms of grip. You can hear the slippage there. But it is up. Let's hope they don't drive off.
Can we just collect 5 points over and over again?
There is only one lot of 5 points available for descending the lander ramp. Unless they go the other way, I'd be open to that. Okay, the rover does not want to go home. It's back on the surface. So after the end of this task, we'll have the RMIT team starting their shot at the iSpace Space Resources task. It's fantastic to see the team have already brought their rover out near the challenge arena. So they'll be ready to go as soon as UniMelb either expire their time or stop finding novelty in driving around like this.
It'd be really nice of them to put the rover right at the front of the competition field so we can carry it away quicker. If anyone in the base station can hear me.
What about if they drove it down the centre aisle and actually back to the workshop during the task time?
That'd be even better.
It seems to be approaching the commentators on the side here. I can hear some sort of noise. It could be Morse code.
No, it's not Morse code. It's
okay. The scoop is moving again, and I note that it is moving the correct way now.
I think it's telling me it works.
Jasper has just indicated that when they plugged in the science module, it wasn't working at the start of the task. And somehow during the task, they have been able to reconnect. And so this could be a message directly to Jasper to say, what were you doing?
Yeah, we scrapped the moving parts of the science module. At least I thought we did. And so I didn't cut the cable tie at the top that would enable the science module to descend. And I think they're trying to demonstrate that it very well could have, and they're not happy with me.
Yeah, yeah. Because like I said, if they get 1 gram of water, they get 40 points. Currently. It's on the clock. 5 minutes. I think that's stored though. They might not realise. They might think that most. While the Rover is still just driving around the course, we are marvelling at the suspension, which you get a nice side-on shot of there. You can see each of the wheels conform to the bumps and lumps that it is traversing now, keeping all 6 of its wheels in contact with the ground. Very impressive stuff. It's not easy at all to do that. And in previous years, teams have struggled with things such as that. They're now mounting the regolith acquisition zone that was used in yesterday's excavation and construction task.
This was a big focus for us from last year. We had a lot of trouble turning, and so the suspension has been completely redesigned, and they've smashed it. So we're really happy with the chassis team for the work they've done on the suspension.
Awesome. Do you know what sort of changes that they made to the suspension?
I'm an electrical engineer, so no.
If you're an electrical engineer, Jasper, can you tell me what an electron is?
No. That's a physicist's job, mate.
Correct answer. Thank you so much. So there's just over 90 seconds left for UniMelb, and RMIT are raring to go by the side of the courts there. As soon as that time expires, the UniMelb team will be whipping their Rover off the challenge arena, and RMIT will be jumping on. Again, it appears as though they are inspecting the paver placement area from yesterday's excavation and construction task. I'm not sure if they have realised that that task did finish about 24 hours ago and that they are doing the iSpace Space Resources task. And who were the judges in charge of this, but leaving the rope from yesterday's task in the field? You guys go into videos and stuff once they're done? Give it up for Unimelb. Make sure. Happy leave this for just like a minute and I'll run through the scoreboard and then chuck it to RMIT and I'll just talk about them before they start. So the leaderboard as it stands there after Unimelb's task attempt. So we will be working behind the scenes to add their score from this task to that leaderboard. But currently, Monash Nova Rover is in first position on 295.3 points. Scorpio is at 245.4. And Unimelb were in third place at 147.4, but will no doubt have some more points to add to that once their points for the previous task are added in. So next up is the RMIT Rover team hailing from Melbourne, Australia in the iSpace Space Resources task. This is the second time that the RMIT Rover team has competed in the Australian Rover Challenge. The first time was in 2021. They then had a break last year and they are back better than ever in 2023. The team has done a lot and been through a lot in those past 2 years, losing a lot of members to graduation and other events. So they're essentially a brand new team. And they've done an incredible job to ready their rover for this year's competition. They will also have 40 minutes to compete in the iSpace Space Resources task, which will start in just under 2 minutes' time. Their current score is 48.1, and there is 100 points available for this task. So you can see the RMIT team is still setting up. They're still on the phone to their base station, making sure they have reliable communications. And once they're ready to go, they will let the judges know. It looks like they're just doing a motor test now. So they're just lifting the left-hand side of the rover up, making sure the wheels are turning, which they are. Oh, the middle one was not, sorry, so they're just addressing that now. Let me double check. Are they timed?
The time has started, but they haven't started a time.
The time that you have up on the screen is correct. Oh, sorry, what was your original question? Beautiful, thank you.
That's very relaxing. It's like Japanese garden.
Those supporters are going down. So their task time has started. The 40 minutes that they have to do this task is counting down. The team can elect to start the task at a time of their choosing once they are happy with the current functionality of their rover. So it looks like the team has confirmed the functionality of their left-hand side drive, and they're going for the right-hand side now, which also seems to be working how the team wants it to. They might go through a robotic arm test now, which is what they're going to use for prospecting the 3 sample sites for this task. And then maybe after that, they'll be ready to go. So the team has given an indication that they have started the task. So that means that all of their team members are clear of the field. The base station door will be closed, and there will be no further communication between those 2 teams. The rover is off the lander, so they've scored their first 5 points. And they should be heading over to the crater to go look at those samples. So one interesting thing about the RMIT base station setup is that they have had some video feed issues in the past, but they've gotten around that by using a first-person view drone setup. So you can see the base station member in the bottom left there has a set of goggles on, which they would be viewing the feed out of one of the cameras on the rover through. I don't know. Dan, like. So we've spoken a couple of times today about just how hard it is to navigate and see where you're going when you're viewing this through a 2D picture or potentially through the goggles that the operator is looking through. It might look easy to us to just be like, it's the crater, just go in there, come on. However, if they're looking through a single image from low down on the rover, they might not be able to see what is over that crater wall, and they have to figure it out themselves. Hopefully they can, and hopefully they'll be scoring some more points very soon. So the couple of things to keep in mind is we don't know if it is. So just like as little and as technical as possible. Yeah. no swearing, as little technical information as possible. Try and like relate it to, I guess, like other concepts that So it looks like the team has called an intervention, which means that they're able to send some maintainers out onto the surface to check the status of the rover. They've got a handheld radio and are in communication with the base station, and they'll check to make sure that the rover is working how they wish. So they'll receive a 10% penalty of the points that they score for this intervention, but it gives them time, and they've got half an hour left of task time, so plenty of time to sort out whatever issue may be going on, and then get the task back underway to try and score some more points later. So it looks like the maintainers have left the field. The judge has the handheld radio again, and the team is likely recommencing the task after that intervention. And away it goes. During the intervention, importantly, the field team are not allowed to relay any information about the environment or the rover's current position in it. So they can't go or mutter under their breath, "You just need to go to the crater, it's just over there. Just go to the right. Yeah, there you go." So they're making their way into the crater, and hopefully they can image some more sites to get some more points. In the meantime, I'm joined by Emma, who's a member of the RMIT Rover team, who's going to give us some more behind-the-scenes information into their rover and their operations. But first, Emma, can you explain what is your role on the team? How long have you been on it, and how's it been so far?
Alright, so I'm a member of Drive Systems on our team, so we work with all the electronics in the rover. We've also had a bit of a hand in the motors and the wheels and suspension. So I've only been in the team since like November, and that's the same with most of our team. I think we have about 3 senior people on our entire team, and the rest is fairly new. Yeah.
Yeah, wow. So you've literally been on the team for 4-5 months maybe, and most of the other team members are in the same boat.
Yeah.
Wow. It's amazing that you guys are here and you've been able to make that rover. Like, how much have you learnt a lot during that time? Are you enjoying your time on the team?
I've learned so much so far. I enjoy it so much, and I think here as a team we're just here to learn and we're here to watch, and we're really happy we're driving today.
Awesome. Do you have a hunch at all about what might have been happening with the rover before we saw the team had to call an intervention? We saw one of your team members pull out a laptop and maybe connect to the back of the rover. Was there maybe a reset that had to happen, or do you have a hunch about how it was happening then?
Yeah, so we probably had to reflash our TNC. We're not running off, we're only running off the TNC as a microcontroller. We're not using a particularly large processing unit.
Yeah, cool. Okay, so the microcontroller being the thing that is driving the whole rover just needed to be reflashed with its firmware, software.
Yeah, reset
cool.
Pretty much. Just turn it off and on.
Turn it off and on. I like it. If it's good enough for the rover, it's good enough for space, it's good enough for my computer. I love it. So it looks like the rover has made its way to sample site number 2. So they get 5 points for navigating to that site, and then a further 5 points for imaging that site. So it looks like the RMIT Rover team are making use of their robotic arm, but have added an additional component to the tip of it, potentially to sense the water concentration or something like that. Without putting you on the spot too much, Emma, do you know what that component is on the robotic arm, and what is it doing?
Yep, so it's just a moisture sensor sending analog signals back to the TNC. Sorry, I'm not a member of the science team, but this guy right beside me is, so.
Awesome. As long as we're getting the right answers, that's good. Yeah, so obviously there's points available for going to the site, points available for then imaging the site, and the greater precision that you can get on the water amount which is in there, the more points you'll achieve in the presentation which is happening after the task. So hopefully it looks like they dipped that moisture sensor into site number 2, and hopefully they can get a couple more sites and increase that knowledge of that local environment. So it looks like the rover is approaching site number 1 now. It's definitely made its way over there. So gotten the 5 points for navigating to the site. So let's see if it goes in with the moisture sensor to that site as well. So it's fantastic to see RMIT off the lander, over in the crater, investigating those sample sites. Unfortunately, you guys haven't had too many successes at the competition thus far. Have you guys been up all night fixing those problems? Because yeah, this is amazing to see. Do you know what has been the updates and progress since yesterday and Thursday?
Yeah, so we haven't got a lot of sleep, especially our command team and our software team. We've had a lot of communication issues. But we've finally got them fixed, and we're very happy.
Awesome. I imagine communication issues between the base station and the rover, not between team members, of course.
Yes.
Hopefully everyone's looking after themselves and getting the bare minimum of sleep, fingers crossed. We don't want anyone's health illy affected by the competition.
Despite the lack of sleep, our morale is quite high, so we're good to go.
That's awesome to hear.
Pass. そういうプログラムになっています。And the purpose of the Artemis program is to return humans, astronauts, to the moon to stay. このアルテミス計画の目的というのは月に戻りましょうと。ただ戻るだけではなくて、その表面で滞在して活動する、これを目指しています。But if we are going to stay, we need to build a small city. So we need to build a home on the moon. その月の表面に
So what you can see on the screen here, we have Associate Professor John Coulson, who's just in the Exteriors Lab on campus, and he's presenting to some people in Japan right now. This is live.
Are thinking of ways to build roads and landing pads and habitation facilities and power plants and all of the things that we use in a city on a day-to-day basis here on Earth.
そのアルテミス計画に関連するオーストラリアとか日本とかさまざまな国の人たちはその表面に街を作るというために、その表面のものをいろいろと集めてきたりとか、それから家を作ったりとか、そういう基地を作るためのいろいろな活動をやっていく必要があります。
And for us, this lab is all about
So, unfortunately, the RMIT rover had to have its emergency stop button pressed. That means that the task has concluded, and this was just done by one of the team members in the field to make sure that the rover did not damage itself. You can see the robotic arm in a little bit of a precarious position there, so that's definitely a preferred result rather than ruining that arm itself. I'm sure they'll want to reuse it in future competitions or in the future. So it does unfortunately mean that the task does stop there, and we'll be throwing over to that the John Coulton's lecture with the Japanese just now.
friends.
で彼が今いるところでそういった基礎研究をやっているところなんですけれども、この基礎研究っていうのはある意味土木工学みたいなもの、その地球外での土木工学みたいなものであって、でその工学の中には物を作るっていうこともあるし、こういったローバーのようなものも運用する、そういったことも含まれます。
So today we have a very exciting program for you where you will be able to drive one of our robots in our lunar test pit to help rescue a NASA robot in our lunar test bed.
それで皆さんにこれから体験していただくことというのは、この月の、を模擬した場所にあるこのロボットを、救出するっていう、そういうようなミッションをやってもらおうと思います。
And we want to thank Drone Deploy, Digital Blast, Tenkyu Space Museum, and the University of Tokyo and Professor Miyamoto for helping to put this program together. We're very excited for the fun that you'll have today.
これが実現したのは彼らのアデレード大学の人たちだけではなくて、ドローンデプロイっていうアメリカの会社ですとか、それからこの全部のオーガナイズをしてくださっているのがデジタルブラストさんっていう、これ日本の会社です。それからあと私たち東京大学およびこの天気のリサーチセンターの人たちのおかげでこれが成立しました。
So I would like to introduce Miles Davies, the manager of our center, to explain the course for you today. Thank you very much.
Thank you. これからマイルズさんという人がこの中身をもう少し詳しく説明してくれるとのことです。
Hello, hello, Space Museum. How are you?
Good. How are you?
Very well, thank you. I will bring up a map of the course.
これから地図、運転するためこのロボットを運転してもらいますけど、そのための地図をお見せしましょう。Yeah, we got it.
There we go. Excellent. So, the course we've designed today is going to be both challenging and fun.
これからやってもらうこのコースは非常に挑戦的だけれどもとっても楽しいところです。
We will drive one of these rovers around the field, starting at the square point where you can see the rover there just on the side of the screen.
ここにあるローバーの一つを運転してもらう形になります。
From the rover pad, you'll drive along a narrow pass and over some rocks to the top of the screen.
これからこのローバー、ここから運転してもらって、この岩、これの周辺に最初に行ってもらう形になります。
At the top of the screen, we want everybody to have a look around to see if they can see a rover or any piece of equipment that might be in trouble.
Sorry, I missed. So we go to the narrow pass first, right?
The narrow pass over the rocks, and then up in the top, you can see a rover right up in the top right-hand corner.
Yeah.
Yeah.
ごめんごめん、ここからこれを通っていってI completely missed it. それで この右上にあるローバーのそばに寄っていってもらう形になります。Okay, sorry, go ahead, please.
No, that's okay. We would like all the drivers, if they could tell us what they see when they see that rover. That's part of the challenge. Tell us what you can see when you get there.
Okay, so just report to you what the
Yes.
Okay. じゃあこのローバーのそばに行って一体このローバーがどういう状態になっているのかっていうことを報告してもらうというのがこのミッションになります。Okay.
And from there, you can drive back to the pad. You can come through the center, through the crater, and over the rocks, or around the side, around the ridge.
Okay. それでwait a minute. Let me make sure. First, you want to drive through the narrow pass first and
Yes.
Avoid the rock or climb up the rock?
Yeah.
Just avoid
Yeah.
it. Which one?
I'll go to the share. I'll go to share. And then the keyboard.
So it cannot climb up the rock, right? So we have to avoid hitting the rock. Is that right?
I'll just bring up the next.
ちょっと待って、ちょっと。
どのルートを行ったらいいかちょっと分かんなくなっちゃいましたね。スタートから行って。
スタートから行って、多分スタートから行って、ここを通って行って、このそばに行って、こいつがどういう状態になってるかを調べて、そこからこのクレーターを戻って、おそらくこう元に戻ってくるんだろうと思うんだけど、ちょっと今確認してるところです。Thank you. Beautiful. Thanks.
How's that?
Yeah, cool. Okay.
That's the answer. I'm giving you the answers first.
Cool. That's great. そしたらこういうルートで行ってもらうと良いかなっていうところです。So the mission is to clarify the status of the rover, which doesn't move on the right upper corner of this field. Is that right? All right.
Yeah, that's perfect. You will control the rover that will go and report on the broken piece of machinery, and then you'll come back to the pad, and then you'll report back.
Okay, cool. Thanks. そしたら、みんなこれを動かしていて、これが今壊れてしまって困っていますので、この近くに行ってもらって、この機械がどういう状況にあるかっていうことを報告してもらって、でその後でこの最初にいた場所に戻ってきてもらう。これが今からみんなにやってもらうことです。よろしいでしょうか。Okay, clarified. Thanks. Yeah.
We'll have people to help if anyone gets stuck.
Okay. もし何かトラブルがあってもうどうしても動かなくなっちゃったりとかした場合には向こうのスタッフが手伝うことができるので思う存分やってください。
All right. Back to Johnson.
So we should have fun. Thank you, Miles, and thank you, Professor Miyamoto.
Thank you.
We look forward to seeing you on the course.
はい。Thank you, John さん、マイルズさん、ありがとうございました。はい。というわけで今からこのコントローラーを使って オーストラリアにあるそのアデレード大学のローバーをここから操作してみようということなんですね。はい、では早速やってもらいましょう。まずは、はい、こちらのお子さんからまずやっていただけますか。はい、じゃあ前出てもらって、一緒にやるはい、はい、ちょっと失礼します。はい。
John, we have two kids here. They are trying to drive.
じゃあ立ってやってみようか。
That's fantastic. We can see them, Rudy. That looks great.
Ah, there.
今まさに動いていますね。こちらが映像ですもんね。なるほど。左がローバーについているカメラ、右が上から撮っている映像でしょうか。
もう動いて動いた。
動いてますね。前に進んでいますね。
Okay.
次はちょっと右に向いて。
これを見て。そうそう。
前に進みました。進んでます。結構早く進んでますね。右の画面でもこう早く進んでいる様子がよく見えます。
じゃあこれがどうなってるかを報告してもらうんだな。はいはい。
どうなってますかね。
さあこれがどうなってるでしょうか。だいぶ壊れてる。He said it is broken. He identified the machine is broken.
This might be correct.
Yes. その通りです。
大正解。
Okay, then shall we go back to home?
はい、じゃあ今度は戻ってきます。
Time to go back to base.
He says the tire is in the wrong direction. I mean, the rover broke. Has a tire.
Perfect answer.
Yeah.
Perfect answer.
Thank you. Yeah. その通り全く正しいです。
そろそろゴールが近づいてまいりました。
これでどうやって戻るのかな。
登り切りましたね。
ここかな。
あと少し。ゴールしました。おめでとうございます。素晴らしいですね。操作上手でしたよね。はい。
Great job.
素晴らしいって言ったよ、向こうの今ジョンさん。He says thank you.
ちょっと今操作してくれた子にも感想を聞いてみたいと思います。どうだった？楽しかった？
楽しかった。
ありがとうございます。
He said it's a great fun.
はいですね、今回アデレード大学のローバーを操作した記念としてこちらのライセンスカードをお渡しします。
So now Miyamata Sensei is passing the driving license.
の証拠、ローバーをうまく運転しましたという証拠でローバーの運転免許証を差し上げます。はい、
運転免許証。
Congratulations.
5歳と7歳の子が
Now moving on to our next candidate.
Okay.
Hey, by the way, the kid just drove is 5 years old, and from now his brother, 7 years old, will try the next turn.
Fantastic. Fantastic.
はい、ではもう一枚。
That is the fastest lap so far. That is the fastest lap so far.
今までのところで最速ですという話をしました。
素晴らしい。
さあ、じゃあ次やってみましょう。OK。
はい。お、進みましたね。
進んだ。
お。
これを避けて。Either way。どっちでもいい。
お、行きましたね。
結構大丈夫。
おお。
結構大丈夫なんですね。
お、でも近くに来ていますよ。
あれ、どこにローバーがあるのか。
ローバーは今右上あたりにもう少しでつきますかね。
これか。
ありました。
さあ、どういう状態になってるかな。あ、変わってる。
さっきとちょっと違う様子が。
はい、じゃあこれがどういう状況になってるかを解説してください。He also says that tire is broken. その通りです。その通り、素晴らしい。
今回も大正解です。はい、じゃあ戻って。
So he's returning to the base.
今あちらにいますね。これ最速出たんじゃないですか、もしかしたら。直線距離で最短ルートでもう少しで到着です。
これはクレーターのへりを登ろうとしているのかな。
お、何か詰まっているような。何かへこんでるのかもしれないですね。
へこんでて。
頑張れ頑張れ。
ゆっくり登ってる登ってる、ゆっくり登ってる。
来た来た来た。
よし、もうちょっとだ。
そこを登り切ったら、今まさに今も降りましたかね。降りましたね。
行った行った行った。はい、
左の画面がリアルでいいですよね。ぶつかったっていうことがわかるので、はい。あともう少しです。頑張れ。見えてきました、ゴールも。はい、到着しました。ありがとうございます。
Good job.
Well done.
素晴らしい素晴らしい。
Miyamoto Sensei is handing over the driving license.
またライセンスカードを
お渡し
します。
ありがとう、おめでとう。
おめでとうございます。
Congratulations.
次やりたい人。
次またやりたい人いますか。一人いました。
Moving on to our next kid.
はい。じゃあスタートですかね。はい、用意スタート。
Okay, she just started.
All right.
ちょっと練習ということで、ちょっとコントローラーを動かしていただきましょうか。
Yeah, she's a little bit practicing right now.
We have to practice a lot here too.
Yeah, I know.
We all need practice.
Yeah, yeah.
なかなかね、見た目よりも難しいんじゃないかなって思います。こうボコボコしてたりして、はい、これちょっとやってみたくなっちゃいますね。
そうですね、わざわざ難しくしてる。
本当ですね。
これは今アデレード大学は8000km離れてるんですよね。8000km離れたところの車を、リモートで動かしているというところがちょっと面白いですね。
そうですよね。もう日本の中でやってるわけじゃないんですもんね。海を越えて オーストラリアという土地と今つながっております。
I am telling the people that we are driving a rover 8,000 kilometers away from Tokyo.
Yeah.
はい。じゃあそろそろ行ってみますか。
左だな。左だな。左に行かない？
あ、今ちょっと動きましたね。
あ、行った行った行った。
あ、行きました。よし。では。
She had a little problem of turning left, but it seems.
あ、スタートしました。はい。
Yeah, she's looking good.
Yep.
はい、よくやってますね。
今新しく到着された皆さんにご説明しますと、これは月を探査するためのローバーを、オーストラリアのアデレード大学でも開発をしていまして、で月と地球の距離は38万キロメートルあるわけですけれども、それを模擬して今オーストラリアでこれ実際に動かしているやつで8000キロメートル離れた東京からこのオーストラリアのローバーを運転するっていうそういう体験を遊びに来てくれたみんなでやっているっていうそういう形です。それでこういう障害物
Hi everyone, welcome to day 3 of the Australian Rover Challenge. We are joined by the Adelaide Rover team, who are our last team today to compete in the iSpace Space Resources task. They are up on the lander, their people are clear of the lander. Their task time does not start for another 3 minutes though, so I'm sure they're working frantically behind the scenes in their base station, establishing reliable communications with the rover as it sits on the lander, and they'll be waiting to start the task any moment now. The iSpace Space Resources task requires them to descend off the lander, go over to the 3 samples that we have prepared over in our simulated crater, go and inspect those, and then go and process the water which is in those samples and try and produce liquid water for the judges. After 2 days of the competition, the Adelaide Rover team has a score of 91.6. They are obviously from Adelaide, Australia, and they'll be competing for 100 points in this task. Like I mentioned, there are 100 points available for this task, the first 5 of which are for descending off that lander ramp and having all 6 of their wheels in contact with our simulated lunar surface. There are further 30 points available for navigating over to our simulated crater and inspecting each of the 3 sample sites that we have prepared. The judges spent a bit of time a couple of days ago getting some sand and putting known quantities of water in each of those samples and then putting them in the freezer for a couple of days. This is to simulate what the sand, or the regolith as it's called, might be like on the moon in the polar regions where it is extremely cold and sometimes never sees any sunlight. In those regions, there can be quite a lot of water, anywhere between 8 and 30% of the weight of the regolith can be water. Because it is so cold, it's obviously very frozen, and it makes it very hard to excavate or do anything with. So this task is particularly challenging. The Adelaide Rover team are making use of their robotic arm with a new end effector attachment on it to collect a sample from those prepared samples, and then it will likely deposit it into the rover and hopefully extract some liquid water. As you can see on the top right of the screen there, the Adelaide Rover team will have 40 minutes to complete this task. That task time has started, but they're still preparing their rover. And they can elect to start the task, i.e. clear all of their members from the field and start operating the rover from their base station whenever they are ready to do so. This is the third year that the Adelaide Rover team has competed in the Australian Rover Challenge. They've competed in every single iteration of the challenge that we've hosted thus far. The team was originally founded to compete in that 2021 Rover Challenge. That is exactly part of the reason why we do what we do, to encourage more Australian teams to join the fray, build a rover, learn new skills, and have fun while doing it. Most of the time. So you can see the Adelaide Rover here is another team utilising the double bogey design, i.e. they have 2 pivot points in those suspension linkages. So each of the 3 wheels on each side of the suspension can move relatively independently. They're also one of 2 teams, I believe, utilising pivot steering, which means that the fore and aft set of wheels can both rotate on the vertical axis so that the rover can turn on the spot, essentially, and also make much tighter turns than some of the other rovers. So that task time continues to count down. The team can start at any time once they're happy with the rover's operation. We've got quite a few maintenance people on the field right now, debugging and trying their hardest to get that rover up and running. Remember, after today, we do have one more day of Australia Rover Challenge action. Tomorrow, we'll have the Boeing Mapping and Autonomous Task from 10 a.m. until about 4 p.m., weather permitting. It doesn't rain on the moon, so if it rains here, everything stops. So it looks like the Rover team members in the field have cleared the field, and so they might look to get underway very shortly. Just waiting for final confirmation from the base station and from the judges that we're ready to go. So you can see on the screen the Adelaide Rover team base station there. They've got 6 of their members who are going to be locked away in that base station for the duration of the task. As soon as they're ready to start, they'll be closing that door, and then they'll be all by themselves left to see what they can see through the cameras and do what they can to control the rover through the activities that are part of this task. It appears as though the Adelaide Rover team are returning to the rover just to debug one final communications issue. It's very important to make sure that communications link is up and robust. If it is not, there's not too much you can do, unfortunately. So there are some size and weight limitations on the rovers that we have here at the Australian Rover Challenge. The weight restriction is 50 kilograms, and the rovers can be no larger than 1.6 by 1.6 by 1.6 meters. This is a bit of a hybrid medium-sized rover. A lot of the rovers that you might think of, such as Curiosity and Perseverance on the Martian surface right now operating, are about the size of a Prius and weigh a little bit over a ton, I believe. There is a lunar rover on the way to the moon right now, landing in about a month, I believe, and that has been manufactured and will land on board the lander of one of the sponsors of the Australian Rover Challenge and the namesake for this task, iSpace. So they launched their Hakuto 1 lander in about October or November last year. It's traveling quite a far distance and making use of some very interesting astronomical principles to get to the moon with as little, using as little energy as possible, so that it can maximize the mass on board for scientific and other payloads. It has a small rover on board, which is about 20 kilograms, and its longest dimension is about 50 centimeters. So if it were here, it could probably piggyback on top of this Adelaide rover if it wanted to.
For those interested, today's task has been taken place inside a permanently shadowed region, so the PSR, in the corner of the crater over there. And the reason why we call them PSRs, persistently shadowed regions, is because they exist at the poles of the moon. So you can imagine if you were to spin a basketball on your finger and it's rotating on a single axis, that's how the moon orbits around the Earth, which means that because the planets orbit the sun on the equatorial plane, the sun's light hits the moon, sort of like if you're looking at the basketball and your face was the sunlight hits the equator perpendicularly, but as you go higher on the equator towards the poles, the sun, if you were on the moon, gets lower and lower on the horizon, so it gets colder and colder. If there were any topographic depressions, so hills or maybe a crater, an impact crater at the poles, it means that sunlight can't directly enter that region. Sort of like if there was a big hill over the horizon, you can't see past it. Same thing happens on the moon or other planetary bodies that orbit perpendicularly. Sunlight can't directly enter it. And the moon has been around for about 4 billion years. So there are regions which have been persistently dark, have never seen the sun for billions of years. This means that it gets extremely cold and remains cold. So we have recorded the coldest surface temperature in our solar system, 25 degrees above absolute zero, 25 degrees Kelvin. Oh, and there goes the rover. It's cold. So we've recorded the coldest surface temperature ever in our solar system inside the bottom of a PSR on the lunar surface. And for this reason, because it's so cold, this means that any volatiles, which means things like water or methane, and a quick round of applause. This means that things like water or methane or other volatiles that exist in the atmosphere that are produced when volcanoes explode or when comets slam into the surface or when the sun interacts with the surface of the moon. This means that they become frozen at the poles because it's so cold, and they stay frozen. And this means that there could be vast deposits of ice on the moon at the poles. And today, here at the Australian Rover Challenge, on this lovely simulated lunar surface, we are trying to simulate one of those craters and getting these students building their rover, which is currently moving off of the lander, and with this descent, they may score the first 5 points of the Space Resources task. Let's see if they get all 6 wheels onto the soil.
So, like Daniel said, we are trying to simulate a permanently shadowed crater on our simulated lunar surface here. The rover is making a beeline for it. They've scored their first 5 points for this task by descending off that lander. There are 30 more points up for grabs for navigating to each of the 3 sample sites we have marked out for them. 40 points available for processing some of the regolith or soil from those sites and making liquid water. And then a last 25 points available for their presentation to Daniel, who is our expert lunar judge, after the task ends. You can see in the pivot steering that those wheels, just like that, can pivot vertically on the vertical axis, which means that the whole rover can essentially spin on the spot. This is a very similar setup to some of the Martian rovers which are on Mars right now, such as Perseverance and Curiosity. So that's likely a further 10 points for the University of Adelaide by navigating to and identifying sample site number 3. Now they're making their way to sample site number 2. They're having a look. By visually inspecting that sample site, they are earning those 10 points. And they're probably looking for any signs of a physical appearance difference between the sample sites. So it appears to be quite a jovial atmosphere inside the base station. I'm not 100% sure what's going on. You can see they're using a blue controller there to control the rover. Likely some sort of gaming controller. Xbox controller. Very good. I'm not 100% sure what is happening in the base station. These are space engineers, I guess, and they are rocking off to make some sort of decision. So after travelling to each of the 3 sample sites, it's likely that the rover has made the team has made a decision about which one to sample from. It might be number 3. Let's see if that robotic arm moves on top. So we've just been alerted that the team has called an intervention. This means that the Adelaide Rover team members who are out on the field here can jump on and see what the issue may be. So they're communicating via the handheld radios to the base station members. Tell them to put safeties on.
Jess, could you please make sure all operators on the field are wearing safety glasses?
That's an excellent point, actually.
Sorry?
Just being a horrible person.
No, you just well, that's the whole challenge, right?
Is being safe horrible?
I just think I wanted to be.
I thought you were just being safe.
I deeply and no one can fault you for that.
So the team will lose 10% of the points that they score in this task for this intervention, and they can spend however long they'd like communicating with the base station and making sure that the rover is operating as it needs to. You can see they removed their top panel to expose the electronics and computer underneath, and are trying to diagnose the issue right now. Once they're ready, they will notify the judges that they're ready to recommence the task, and then they will be able to go on and score more competition points. I believe at the moment they'll be sitting on around 35 points. Importantly, no team today has been able to process to get any liquid water. And because of the scoring, the 40 points available for getting that liquid water is based upon how the mass of the team that gets the most liquid water. If they are able to get any at all, just 1 gram, they will get all 40 of those points. So I believe the intention here is if they do get the rover back up and running, the robotic arm will reach over to sample number 3 and try and collect a sample and then deposit in the almost metal funnel looking device in the front of the rover. Awesome. Awesome. So we've got an interesting phenomenon happening on the Challenge Arena right now. You can see the sun is reflecting off Ingani Wardley, the building on the left, as you look at the Challenge Arena from the stands. And it's casting these quite large shadows over the solar panels on the lander. So you'd note that solar panels on roofs in Australia are mostly flat, and this is to capture as much of the light as possible and generate the most electricity. On the moon, however, well, basically only near the poles, because like Daniel described before, the sun is at quite an angle if it does ever come above the surface or rise in that area of the moon. Often the solar panels that you deploy on a rover or a lander system near the poles will actually be vertical. This will capture the most amount of power at that point, and it's really interesting to see that we've got that reflection and that happening on the lander itself here. None of the rovers that we have at the Australian Rover Challenge utilise solar power, of course. Most of them are using chemical batteries, which are rechargeable, and they'll make sure that they are fully juiced up before each task. It'd be a real shame if their battery went flat during the task. You can see on the back of the rover that it's fitted with an emergency stop button. It's the red button with the yellow surrounds there. It's up to the team if the rover is going to endanger itself or anyone else to hit that button, which will immediately stop any of the power draw from the batteries and immediately terminate what the rover is doing. This is a safety measure which is used with most robotics which interact at any point in the vicinity near any humans to make sure back in 2019, when the Monash team were competing in the University Rover Challenge in the United States, they were competing in one of the tasks there, and their robotic arm actually hit their own emergency stop button accidentally. The team in the base station assumed that the comms just went dead, that the line of sight was obscured by a hill or something, but were quite surprised to see, watching the video replay, and when they got to the rover to inspect it, that the emergency stop had been pressed, even though no one was near it at the time. A member of Monash Nova Rover has just let me know that that information was not public, so that stays between all of us, including all of you online. We know that you're watching. Funnily enough, the director of student teams at Monash University, Scott Wordley, who is with us this weekend, not in the vicinity right now though, he actually founded Monash Motorsport, and he let us know when that happened that the Monash Motorsport car, when it was competing back in around 2010, I believe, had the exact same thing happen. So it must run in the Monash family. I've just heard the words, "It's good," from the Adelaide team. So hopefully they're about to recommence. And if they can move back into that corner to stop obscuring the camera lines, that would be really good.
Can we actually get them?
Yeah, we'll do. So there's just 3 minutes left in the task. Let's cross our fingers and toes that they can get the rover working again. And maybe they'll be able to pick up some of the watery regolith out of sample site number 3. They're still just confirming that their communications are back online, and hopefully they'll be ready to go any minute now. So as we've all seen, the robotic arm has moved. So we've got a great view of that auger or drill bit on the end of Adelaide Rover team's robotic arm there. They've only got 1 minute to see if they can get it over to sample site number 3 and see if they can dig up any of that sample. Either way, this is a fantastic proof of concept to show that it does demonstrate and it does operate in its intended purpose. So hats off to the Rover team, the Adelaide Rover team, for being able to show that.
It would be nice.
Well, folks, that's the end of the task. Let's put it together for the Adelaide Rover team. So by my calculations, it would appear as though the Adelaide Rover team would have scored 31.5 points in that task. They scored 5 points for descending off the lander, another 30 points for making it to each of the sample sites. However, they did receive a 10% penalty for taking that one intervention. Howdy. They're going to work to get their rover off the challenge arena now. And they're probably going to be working overnight to make sure that their rover is ready for tomorrow's Boeing mapping and autonomous task. They're the last uni to compete this for today. Join us again tomorrow from 10 a.m. Adelaide time, where we'll be starting the Boeing mapping and autonomous task. If you are joining us here and you would like to join us tomorrow, have a look at the board with the schedule on the entrance on the left-hand side as you look at the challenge arena. That will have the times that each university is competing tomorrow. This is the current leaderboard as it stands, but we are still waiting to update some scores from the presentations and, of course, from Adelaide's effort just now. We'll be working to update this behind the scenes, and then we'll push this to the leaderboard as soon as we can. Once again, thank you everyone for joining us on day 3 of the Australian Rover Challenge. We appreciate you coming on this journey with us. We are 75% of the way through the challenge, and we'll be hosting the 4th and final challenge tomorrow from 10 a.m. Adelaide time. If you're tuning in online, the stream will go live at about 9:45 Adelaide time. We'll see you then.
Australia is a nation of creators, aviators, protectors, and innovators. From aviation's first light to the dawn of the jet age and beyond, at Boeing, we're building the future together here in Australia. Inspiring those in pursuit of new frontiers, connecting, protecting, and exploring our region and the world. Home to the broadest aerospace portfolio in Australian industry, powered by talented, dedicated, and diverse teammates. Delivering manufacturing excellence, building composite aircraft parts for the world's most efficient airplanes, using advanced robotics, materials, and digital technologies. Never compromising on safety or quality, always focused on sustainability. Solving tomorrow's problems today with Australia's leading researchers, scientists, and universities. Developing new military platforms and communications networks, and helping ensure they are always mission ready. Keeping customers airborne by providing the services they require. We stand shoulder to shoulder with Australians during natural disasters, on the front line, and in peacetime. We support veterans and our community, and we nurture the next generation of aviators to excite, to be bold. Boeing Australia. Made in Australia, by Australians, for the world.
Okay, are you ready? The first university to admit women, 2 Nobel Prizes, then another, then a couple more, 12 knighthoods, 22 Olympians, a pack of COVID-sniffing canines, Australia's first female Prime Minister. Finally, treatments for diseases and other scary things, the first female Queen's Counsel, Supreme Court Judge, and State Governor, all in one. First in the family with a degree, a black belt, a robot. First Aussie to walk in space. Helped detect gravitational waves. Made lots of babies. World top 100 in all. This stuff. Launched a satellite. Revived lost languages. Home to 1,600 brainiacs. And a winery. All in the heart of Australia's most livable city. So, what's next? Make history at the University of Adelaide.